Hey, what's up everyone and welcome to Daily Code Buffer. In this video, what we are going to do is we are going to learn event-driven microservices using Spring Boot. So we are going to learn the different design patterns, different architecture design patterns to learn more about the event-driven architecture. So we are going to learn about the CQRS design pattern and we are going to learn about the Saga design pattern. Why these two? These are the mainly used design patterns in the microservices, which will allow us to create a very scalable applications, and Saga design pattern will also allow us to create the microservices that will handle the distributed transactions. Now this is a really long course, so I will suggest you to practice alongside you watch this particular video, so you will get more understanding about the concepts itself. I'm not talking about what is the particular code that you have to memorize, but understand the concepts. Concept is more important. In this particular video, we have used the Axon server and Axon framework alongside Spring Boot, but the same can be implemented using the different frameworks available as well. Now, if you are enjoying all these particular courses that I am developing in this particular channel, then please support me while subscribing to this particular channel and giving a like on this particular video. You can also support me by joining this particular channel by clicking the join button below. So please do support me if you are enjoying all these particular videos. Now, without any further ado, let's get started. Now in this particular video, what we are going to do is we will be first going through the theoretical part and then we'll be implementing the practical example of CQRS. So let's first understand what is CQRS. CQRS means command and query responsibility segregation. So that means we'll be segregating the responsibilities of a command and a query in a different way. So to understand what a command is and what a query is, let's first understand our traditional flow, our traditional architecture, how we are building the application, and how we can improve upon to implement the CQRS. Now, one thing to understand is this CQRS we are going to implement using the event-driven microservices. So whatever we will be building here today, that will be a event-driven microservices, and we'll be using the event sourcing to interact with each other. So first, let's understand the standard structure over here. So in the standard structure, you might have seen multiple times, like we will be creating the APIs. Those APIs might be having the different HTTP method types, that is get, post, put, delete, patch, and the others options and all, but these are the mainly used. So you'll be creating the API and your API will be controlled by your controller layer. So that controller layer will be responsible for traversing the request to the each of the different services that you have in your application. So from the controller, your request will be going to the service layer. That service layer will be responsible for your business logic. So whatever the business logic that you have for your application that you are building, all those particular logic will be written in the service layer. And from the service layer, you will be calling the DAO layer or the repository layer to save your data or to persist your data into your database. So this is a very standard structure for creating the Spring MVC applications or a standard microservice services as well. But here, let's understand the CQRS architecture, how it is different from the normal architecture and what are the different things that we are going to see over here. Now the first thing you can see over here is we will be creating the APIs over here as we are creating the APIs in the standard structure over here. But the only difference is how and what are the different HTTP methods that we are going to use. So all the method that is to fetch the data, so that is the get method, we'll be implementing the get method to fetch the data. That particular will be implemented by the query API. And all the other methods, that is post, put, delete, and patch, those are used to add the data, update the data, or modify the data. That will be implemented by the command API. So this is the two differences. Whenever you are providing any command to your application to do any of the operations, that will be handled by your command APIs. And whenever you want to fetch any data that is already been added in your system, to fetch that, you will be using the query APIs. Now the differentiation of this command API and query API is the core concepts behind the CQRS. That is to segregate the responsibilities of the commands and your queries that you have in your system. Now ideally, when you develop the system, both of these particular commands and query will be in the different services, so you can configure your system according to the need of the application. So you're creating the query API, you can tune the application to get the data, and when you're using the command API, you can tune the application to store or update the data in the database. So for each and every command API and the query API, the main thing that you are going to do is for the command API, you will be providing the command to execute any of the command, and for the query API, you will be providing the queries to fetch any of the data available. So these are the two things that you will be providing in the system to do any operations over here. Now for the command, to handle all this particular command, there will be a command handler that will be handling the command, and for the query there will be query handler that will be handling the queries. Now this particular command handler is also known as the aggregate. When we will be developing the application, we will be creating the aggregate. That particular aggregate will be handling all the commands, and for the queries we will be creating the projections. That particular projections will be handling your query handlers. You can create the command handler classes as well and the query handler classes as well, but you can also create the aggregate and the projections as well. So I have seen multiple places where people have been using aggregate and projection and command handler and query handler as well. And for each and every command or each and every query that you handle, you will be creating the events. So with that particular events, your system can handle all the particular operations, because we are going with the event driven architecture over here. And all these particular events will be stored in the event store. Now for the command API, we will be storing the data in the write database. So that means whatever the operation that we do, that particular database is configured for writing the data to the particular database. And for the query API, we will be using the read database, which is configured for reading the data from that particular database. So this is a very basic level architecture that I am showing you over here, but in the end there is a lot more components that goes inside this particular architecture. So whenever you store any of the data in your read database using the command APIs, how that particular data comes to the read database. So those data comes using the events as well. So for those also, for those type of operations also, we will be creating the events to store the data from the write database to the read database. And there are a lot more different concepts available about snapshotting and a lot of things available. So you can go through the documentation and you can learn more about the CQRS and what are the things we can do to improve the performance and the other aspects of the application. But today here we are going to understand the core concepts about the CQRS architecture and how to implement the CQRS using the Spring Boot and the Axon server. Now Axon server provides the ability in the Spring Boot application to handle all our different events and commands and store all those particular data in our event store. So what we'll be doing is we will be using the Axon server as well. That particular Axon server will store all our data, and we'll be using the Axon framework to interact with that particular Axon server. Now let's understand the data flow for our command API. The similar thing would be available for the query API as well. So let's go and understand this. So this is a CQRS command API flow where we have taken the example to save one of the products. So we have a product service available and we are going to save that particular product using the post request. So here you can see that we have an API that is /products and we are doing the post request over here. And we'll be having one controller. This particular controller will be handling all our API request, and based on the particular APIs that we are going to call and based on the different HTTP methods, we will be sending the command to our command gateway. So what is the command over here? Here you can see that I have created the command that is create product command. So I'm going to create a new product using the post method over here. So I have added the command create product command. You can create multiple commands like update product command, delete product command, okay, based on the requirements. And that particular command I am sending to the command gateway. And I have created the aggregate as well. Aggregate is nothing but the command handler over here, which will handle whatever the command that we are passing. So this particular aggregate will handle this particular create product command, and whatever the operation that we have to do like validations and all those things, we can do all those particular validations. So we can create the event like product created event. So if whatever the data that I'm passing over here, if I think everything is okay, then I can create the event, okay, product created event, and that particular event will be stored in the event store. We will be creating one event handler. That particular event handler will listen all the events that are been created and stored in this particular event store. It will try to listen all those particular events and it will complete those events. So in this particular event handler, what this particular event handler is doing this, it is trying to listen this particular product created event over here. So whenever there is a new event, product created event created and stored in the event store, it will consume that, or it will listen that particular event, and this particular event handler will store that particular data into our database using our repository. So this will be our write database. So here you can see that this is the entire flow, event driven architecture flow for our command for the CQRS, for the command part. This is the flow that we are going to use to create the different commands and create the different events according to that particular command, and handle those particular events. For the query API, this will be very similar. There will be a controller that will handle that particular APIs. Instead of command gateway, there will be a query gateway that will handle those queries. Instead of aggregate, there will be projections that will handle those particular projections, and the same we will be having the event handler to handle the different events, or we can directly send the data from the projection as well. So based on the different architecture, we can code this particular application. So this is a very standard thing that we are going to create over here. So we'll be creating this particular product service to create a product and gather the data from that particular product. So this is the same flow that we are going to create. One controller that we are going to create, an aggregate, an event handler, and a repository for saving the product. So let's go and code our application. Now before that, whatever this particular event store is available over here, right? So let's understand that particular event store as well. I will go to the Axon server website, and from there only I will try to explain you. This is the particular event sourcing available. So we'll be using this particular event sourcing technique, and this particular Axon server uses this particular technique to store all of the particular events. So whenever we create that particular event from our command gateways, all the particular events will be stored in the event data store over here. So suppose if you see over here, they have taken the example of the ordering the pizza over here. So these are the different steps available. You have selected one pizza. Again, that is the one transaction. And on top of that, you have selected the cola as well. And you can see that you have selected the ice cream as well. And you can see you have deselected the ice cream as well. So there are a lot of events happening. First you are selecting the pizza, then you are selecting the cola, then you are selecting ice cream, then you are removing the ice cream, okay, and then you are confirming the order. All these particular different events are stored in the event data store, and all these particular events at the end will result in a single data that is being read by the RAID database. So all these particular events will be executed and it will result in a single order over here. So that particular order will be stored in the database over here. Now, why this particular event sourcing is so helpful is whenever you have any issues or you want to recreate the same order, you can play the entire this particular event source from start to end to create the same data that you want. So you can always go ahead and select a pizza, select a cola, select ice cream, deselect ice cream, and order it. So that way you will be able to recreate the same order multiple times for our debugging purposes, or you want to create a new database. A lot of things that we can do using the event sourcing over here. So you need to understand about this particular event sourcing as well, that we are going to use this in our application. And I will add this particular link in the description below so you can check this out. There is a lot of things available. You can see that this is particular event sourcing, and yeah, you can see that you can create the snapshot as well. You can do the event replaying as well from the code as well, okay? And a lot of things are available. You can go ahead and check this out as well. Now what we are going to do, we are going to first download the Axon server for our application that we are going to create for the product service, and we are going to use this Axon framework along with our Spring Boot. So if you go to this particular Axon IQ/downloads over here, okay, you go to the axoniq.io over here, and if you go to the downloads over here, either you can use the Docker to run your Axon server, or you can download the zip file as well. So I'm having issues running this particular Axon server from the Docker in my M1 Mac, so I'll be using the Axon server download zip file over here. Okay, so I'll be downloading the zip over here. Once you download this particular zip over here, you can unzip that and you can start this particular server. I will show you how to start the server as well, but if you are running Docker, you can directly run this particular command and your server will start automatically. Now let's go to the Spring Initializer and create our project. So what I'll do, I'll just go to the start.spring.io, and here I will create the project. What I'll do, I'll just say com.daily code buffer, and I'll say this is product service. Packaging is jar, Java version is 11, and Spring Boot version is 2.5.4. And let me add the dependencies. I will add the Spring Web dependency, and I will add the Lombok dependency for our boilerplate code, and I will add the JPA dependency over here. Here I am using the H2 database over here, but this particular thing will work in any of the database. Okay, that's it. Let me generate the project and open in IntelliJ IDEA. Now here you can see that I have opened the project over here, and it is resolving the dependencies over here. So I'll wait for a couple of seconds to sync all the dependencies over here. Okay, this is our product service over here. And here what I'll do, let me go to the browser, and if I go to the download Axon over here, you can download this particular zip file over here. And once it is downloaded, you can unzip it over here and open the terminal over here. You go to cd downloads, Axon server over here. Okay, and you can see that this is your jar file over here. So to run this, what we'll do java-jar Axon server .jar over here. Okay, and we will run this. And here you can see that our Axon server is started over here. So it is running on port 8024. So let me go ahead and open that. I'll go and open localhost 8024 over here, and here you can see that this is our Axon dashboard over here. So here you can see that how many events are there. You can see the overview. This is my Axon dashboard server. No other application has been connected over here till now. You can search all the different events and snapshots available. Let me just enable the live updates for now. And here you can see that different commands, whatever the commands that you create, those particular commands will be populated over here. Different queries will be populated over here. So this is your Axon dashboard server. So we'll keep this aside and let's go to the project over here. And let's go to the pom.xml file. In here we need to add our Axon framework. So if you go to the Axon for Spring Boot Maven repo. So this is the one that you need to use, Spring Boot starter module for Axon framework, and the latest version is 4.5.3. So I'll just copy this particular information and let me just add in the dependency at the last. And this particular Axon framework also needs the Google's Guava dependency as well. So I will add that as well. I'll search for the Google Guava and I will use the 30.1.1-JRE version. So I'll just copy this as well and I will paste this also. I'll refresh the Maven over here. So let it resolve the dependencies and then we can go ahead and start our application. Now let's go to the src main folder over here in the resources. Let's add our properties over here. What I'll add, server.port equals to 8081. Now this particular event driven microservice will work with all the Spring Cloud modules over here. For that I have already created a video that you can see over here, that is microservices using Spring Boot. There we have covered all the Spring Cloud dependencies and Spring Cloud project as well, and all this particular thing will be applicable here as well. But we are focusing on the CQRS, so we'll be just doing the simple application using just the CQRS and we won't be implementing any service registries or API gateways over here. Okay, now you can see that the dependency has been resolved over here, and now let me add the properties for the H2 database. So here you can see that these are all the different properties that will help to use our H2 database. So what I'm doing over here is I'm using spring.datasource.url equals to jdbc h2 file /data/product db over here. So this particular H2 database will store all the data not in memory but in the file at this particular location over here. Okay, and I'm using the H2 driver over here. So I have defined in the driver class name. This is the username and password over here for my database, and the platform I'm using is Hibernate Dialect H2 Dialect over here. And this particular spring.h2.console.enable equals to true I have mentioned over here. That will allow us to open the H2 console, and Hibernate DDL auto equals to update. And if you want to know more about this, all the different properties and how the JPA works, I have created a dedicated video about Spring Data JPA. You can check that out as well. Now what we'll be doing is we will be creating the different, so this is my main application file over here, and now we have to create the different packages and we have to create the different application files. So let me go ahead and create the different packages. So what I'll do, I'll create the package command.api for our commands. I'll do query.api for our query API, and inside this particular command.api we can create the different packages based on the different need, like controller, aggregates and all those things. Okay, so here what we are going to create is controller, aggregate and the repository layers and everything. Okay, so we'll be creating this commands events as well. So let's go ahead and create that. So let me just create the another package, that is command.api.controller over here. Let me create one more package over here, and instead of controller I will say model, and inside this particular controller package let's create our controller. So I'll just say product command controller over here, and I will annotate this particular class with REST controller over here. So this is a REST controller where we can interact with the JSON data, and I will also do request mapping over here, and I'll say products. Now let's create a method that we'll be using to save the product over here. So what I'll do, I'll just say public string add product over here, and this will be post mapping over here, and this will return product added. Simple thing over here, but we need to add the product, so we need to get the data from the JSON as well. So we need to have a REST model as well that we will be collecting the data from. So let's create the REST model for that. So in the model we will create one class over here. We'll say product REST model over here, and here we'll be having the different properties. So I'll just say private string name of the product, private big decimal price, and private integer quantity over here. These are the three fields that I'm adding over here, and I will annotate with @data over here and @builder over here using the Lombok over here. So we can set all the values and we can get all the values. Okay, and let me use this particular product REST model in my command controller over here. So I'll just inject it over here, product REST model, and this particular product REST model should be request body. Okay, so this is a pretty standard implementation of our REST API. Okay, now what we want to do is from this particular controller we need to send this particular data to the command gateway over here. So let's create the object of it. What I'll do, I will create object of command gateway, that is the part of the Axon framework over here. I'm creating the object over here, and I will inject using the constructor injection over here. Okay, add constructor parameter over here. So this is a particular command gateway that we can use, but what we want to send the command, that is the create product command over here. So if you go to this particular slide over here, what we are doing over here is we are sending the create product command over here to the command gateway over here. So we need to create this particular create product command as well. So let's go ahead and create that. We'll go to this particular project and we will create the command. So we'll create the first package, command API dot commands package over here, and inside this particular commands package I will create the create product command. Now all these particular commands and events will be having the state of what we are going to do. So suppose I am going to save a particular product, so this particular command and this particular events that we are going to create should store the state, should store the payload of what I am going to do. So that way only whenever we are creating the event and whoever is consuming the event will get to know whatever the data is available and what I want to do with this particular data. So always whenever we are creating the command or events, we'll be storing the data, we'll be storing the payload inside that particular object. So for this particular create product command also we will do the same. First let me annotate with data and builder over here, and if I go to this particular product REST model, I just copy this details over here and I will paste in this particular commands over here. Okay, now alongside all these details there will be always one identifier. Okay, so that will be your product ID. So let me add that product ID as well, private string product ID as well. Now for each of the particular command and the aggregate that is handling your command should have something in common. So there will be a multiple products available, and your aggregate, that is your command handler, will be handling all those particular products. So for all those particular products, your product ID is unique. So that particular product ID should be annotated with some annotations so that your aggregate will understand that this is my target and this is a particular ID that I have that will match that particular two IDs, and accordingly the data has been processed. So for this particular product ID, I will annotate target aggregate identifier. Okay, so when we'll be creating the aggregate, that is your command handler, we will be having this particular field over here that it will interact with. Okay, so both this particular command and aggregate will compare these two particular fields to match these values. So once we implement this, you will get a more clear understanding why we are doing this. Now we created the command, so I need to add the payload data to this particular command, and I need to send this particular command to my command gateway. So let me go to the controller, and here what I'll do, I'll create the object of this particular create product command, create product command dot builder dot build over here, and I will add all the values from the product rest model. So I will just set the product ID as uuid dot random uuid dot toString over here, dot name as product rest model dot get name, dot price as product rest model dot get price, dot quantity as product rest model dot get quantity over here. And here you can see that your object is created and you have set all the fields, all the data that you got from the API request to your command over here. Now you need to send this command via command gateway. So what I'll do, I'll just say command gateway dot send and wait. So send this particular command and wait until this particular command is been completed. And I will send this command, that is create product command over here. Now this particular method will return the result over here. So let me take the result out. And let me send the result back over here. So your controller is ready. That particular controller is sending one command to your command gateway. Okay. Now we need to have the aggregate. So if you go to this particular example, you have sent this particular command to your command gateway. Now you will be having one command handler or aggregate, whatever you want to call. So this particular aggregate will handle this particular command. So let's go ahead and create this aggregate over here. So let me go to the project over here in this command API. Let me create one package over here. And I will see this package as command.api.aggregate. And I will create one Java class and I'll say this is my product aggregate, and I will annotate this particular class as aggregate, and this is the part of your Axon framework, and this is a stereotype annotation. Now your product aggregate will also have the payload data. So go to your command, copy this particular fields over here, go to your product aggregate and paste all the fields. Okay, and here if you go to your create product command, you have mentioned this is a target aggregate identifier, but in your product aggregate you will define this as aggregate identifier. Okay, so this way this particular product ID and the product ID in your command will match, and all the operation will be happening, all the events will be happening for this particular entire data, and this will be identified using this particular product ID over here. If you go to this particular product aggregate, so for this product aggregate to work, you need to create the constructor. That constructor is taking this particular command over here. Okay, so let me create the constructor over here. Okay, and this particular constructor is taking or is injecting this create product command. Create product command. And this should also have a default constructor as well. So let me create a default constructor as well. So I've created a default constructor and a constructor that is taking a command as an input parameter over here. Now what you can do over here, you can perform all the validations over here. You can perform all the different validations and whatever you want to do over here, you can do using this particular command, and once that is done, you need to create the event over here. Okay, So what event that we are going to create over here is, you can see that once that particular aggregate is handling that particular create product command, this aggregate will publish the event that is product created event. So we need to create this particular event and we need to publish that event, which will store into your event store. So let's go ahead and create this particular product created event first and then we'll publish it. So in this command API, we'll create one package over here and that will say events, and in this events package I will create one class and I'll say product created event. This particular product create event, this also should have the payload data, so I'll just copy these fields over here and I will add in the product created event, and I will add the class with @data, @builder, @all-args constructor and @no-args constructor. So these are all the Lombok annotations, so it will be helpful to create the objects of a product created event. Now this particular aggregate will publish this particular event. So we need to go to the aggregate, create the object of product created event, and we need to publish it. So let's go to the aggregate over here and we will create the object that is product created event over here equals to product created event dot builder dot build. So what you can do over here is, you can get all the values from this particular create product command and you can pass all the values over here, or you can use the bin utils over here to populate all the fields over here. As we have all the fields common over here, we'll be using that. Okay, so you can use this builder pattern as well, or you can directly use this particular way as well. So what I'll do, I'll just creating the object over here and using bin utils dot copy properties over here. Here you can define the source, that is create product command, and what is your target. Target is product created event over here. So all the properties from this will be copied, all the values from this particular properties in this particular object will be copied to the target. Okay, as we have the same names available, it will copy all the values. Now what I want to do is, I want to publish this event, so I'll use the aggregate lifecycle over here dot apply, and what is the payload, that is the product created event. So this will publish this particular events. Now for each and every aggregate that you create, you want to use the event sourcing handler over here to update your aggregate values. So whenever you handle any of the particular command, okay, in your command handler or the aggregate, and whenever you publish the event, you need to update the aggregate state of the aggregate. What are the fields or what are the values is been changed. So whenever this particular create product command is been handled over here and the product created event is been created, all these particular fields we are updating from this particular create product command, right? So we need to update all these particular fields over here. So whenever there is a new command, that is the update product command, so at that time whatever that update is happening, we need to update that value as well. So all this, whenever we do that event sourcing update, that particular values will be stored in your event sourcing data, where what we saw earlier, right? What was the event sourcing? So that way all those particular values will be stored in your event store, and whenever we want to replay it, it will be easier for the application to replay all those particular things. So always remember that whenever there is a state change from the aggregate over here, whatever aggregate that you create, whenever there is a state change, update the values over here. So for this particular command handler, whatever we are handling over here, we are changing the state. So all these particular values were not there before, now we are setting this particular values. So we will create one handler, event sourcing handler, to set all these particular values. So I'll just create the handler. So I'll just say public void on what event it should occur is product created event. So I'll just inject that product created event, and I should annotate with event sourcing handler over here. So whenever this particular product created event will occur, this event sourcing handler will be executed to handle the event sourcing data. So what I want to update all the fields, right? So I will update all the fields. I'll just say this dot quantity equals to product created event dot get quantity. This dot product ID equals to product created event dot get product ID. This dot price equals to product created event dot get price over here. This dot name equals to product created event dot get name. So this is your event sourcing handler. So make sure that whenever you are handling the command, you should be having the event sourcing handler to handle the state of that particular command over here. So every time these two will be go hand in hand always. Okay. Now for this particular product aggregate, in this particular product aggregate only, if you want to handle the different command that you have, then you don't have to create the constructor. You can create the method also that you can implement, because it only requires one particular constructor with a particular command to register this. After that, you can create a simple method that is public void handle and handle this particular command. Okay, that also you can create. It's easy. So now your aggregate is also created. Now we have also already published the event, that is product created event, to our event store. Now we need to have the events handler that will handle the event. Okay, that will listen the event from this particular event store and it will save the data to the repository over here. So let's go ahead and do that. Let me go to the IntelliJ IDEA, and what I want is I need to have the event handler. So in the events package, I will create the event handler. I'll create Java class product events handler over here, and I'll annotate this with components so it's in the Springs radar. Now this particular products event handler will be handling the product created event that has been published from this particular aggregate over here, right? So this particular product created event is been published, so we need to handle it in the products events handler over here. So what I'll do, I'll just create the method public void on product created event. Now you can give any name to the methods over here, but in the documentation they've used this particular method, so I'm just using this. And I need to annotate with event handler from the Axon server. Okay, this one. Now we need to handle the event over here. What we need to do is whatever the data, whatever the payload that we are getting, I need to save in my database. So I need to have the entity and I need to have the repository for it. Okay, so let me create the entity and repository for it. So what I'll do, I'll just create the package over here for the repository and that data. So I'll just create as a data over here, and this particular data package will contain the entity, and I'll create the product entity, and I will copy the values from the command. So all these particular values I need, and I will add in the entity over here. Okay, and this particular class I need to annotate with data for the getter setters and @entity for creating this as an entity over here, and I need to annotate @id for my primary key. So this is my entity created. Now for this particular entity I need to create the repository. So let me just create the repository. I'll create the Java class and the interface, and I'll say this is product repository. Okay, and this particular product repository will extends JPA repository, and the type is product entity and the ID type is string. Now if you want to know more about how to create the product repositories and everything, I have a dedicated course for the Spring Data JPA that you can check that out. Now I need to inject this particular product repository into my events handler, so I can use this particular interface and I can save the data. So let me go to the product events handler over here, and let me create the property over here, private product repository. Let me inject using the constructor. Now I can use over here. So what I can do, I can just create the object of a product in the event handler equals to new product, and I'll just use bean utils dot copy properties from event to product, and I will use product repository dot save to save this particular product. That's it. Entire flow is done now. Okay, so we just created this entire flow over here. We created the controller that will handle this slash products for the post method over here, and from this particular controller we are sending the create product command to the command gateway, and whatever the data, whatever the command that we are sending to the command gateway, we are handling using the aggregate over here. Okay, make sure aggregate is your command handler, projection is your query handler. So we created this particular aggregate, and this particular aggregate is handling this particular command, and whatever the operations or whatever the business logic that you have, you can use this particular business logic there, and you can publish the event over here. And we are publishing the product created event, and that particular event is been stored in the event store. After that, we created the events handler, that is the product events handler. That particular is listening this particular product created event, and whenever that particular event occurs, we are using the repository to store the data in our database. So here you can see that whatever the standard flow, standard structure, it was only 3 layers we are using. Now we converted entirely into the event driven architecture, and we are also using the CQRS architecture to store all the data over here. It's pretty neat and pretty easy, right? Now let's go ahead and let's test this out. Okay, so what I'll do, I'll just go and let me just start this server over here, and let me just recheck once that my application is working on port 8081, and these are all the fields for my H2 database. So let me just start the server, and here you can see that my application started on port 8081. Let me go to the browser and let's go to the localhost 8081 / H2 console over here, and here you can see that my JDBC URL is the same. Let me just reconfirm it. Okay, product db /data. Okay, and this is the same. Your username is SA and password is password, and let me connect. And here you can see that this is the product table that has been created over here, and this all the different tables are the part of Axon server. Okay, so let me just run this, and here you can see that there is no products available, and this is clear, right? Now let's go to the Axon server over here, and if you go to the overview, here you can see that this is the application that we have started, and this is the instance that has been connected to the Axon server itself. Now you might be wondering how it directly got connected to this particular Axon server, right? Because we just added the starter for the Axon framework, right? So there will be a default configuration added to the Spring Boot application. So using that default configuration and the default port information, it is connected to the default port for the Axon server. Now if you want to change any of the details, there is a documentation link I will add in the description below. You can check that out. It will help you to change how you can change the Axon servers, how you can deploy the Axon server, and how you can connect your Axon framework application to this particular Axon server as well. So these are all the different properties available that you can use to connect to your Axon server using your Spring Boot application. By default, with the auto configuration, it will work just fine. Now let's go to the Postman and let's head that particular URL that we have created. Okay, so let me just open the Postman over here. Let me do the http :localhost. This should be 8081 products. This should be post request. I'll add the body, raw, JSON data. And if you go to this particular product rest command that is in the model, and let me add these properties over here. Let me store the products. Store mango, price is 100, quantity is 2 over here. Okay, so this is one product that I'm going to store over here. So let me hit on send, and we got the 500 internal server error. Now why we got this particular error, let's go ahead and see. And here you can see that the error is no handler for command, that is create product command over here. Okay, so let's check that. If you go to the aggregate, and this is the create product command handler, and we forgot to add the command handler annotation over here. So let's just restart the server, and here the server has started. Okay, and if you go to the Axon server, Now we should be able to see the command as well, right? Now here you can see that the command has been detected over here, so we should not be getting that error now again. And let me just relog into the H2 console as well. Let's connect it, and there should be no products available. Okay, that's fine. Now let's go to the Postman and let's hit on send again. And here you can see that we got the 200 success and we got back the ID available. Now let's see what happened over here. If you go to the console, everything is okay. Now if you go to the Axon server over here, and if you go to the search, here you can see that if you see the about the query language, here you can see that this way you can get the details over here. Okay, so with the aggregate identifier, let's copy this, let's paste this information, and let's copy this as well. And let's search, and here you can see that this is the particular event identifier. Okay, event over here. So here you can see that this is event identifier, aggregate identifier, and the payload as well. So here you can see that this is the payload information, that your price is 100, quantity is 2, and the name is mango. This is in XML data, but we can always go ahead and change to the JSON as well in the configuration of this particular Axon server. So all these particular details you can see you will get from here, and if you enable the live updates over here, all these particular events will come over here directly. And if you go to the H2 console over here, and if you run this particular query again, you can see that we store the data in our database as well. You can see that the entire operation completed successfully. We were able to create a command. So this particular entire flow, this one is completed successfully. We have the controller, we created the command, we send that command to the command gateway. We created the aggregate that is handling that particular command, and we are creating the event from it and publishing that event to the event store. And we saw the events over here as well in the Axon server in the dashboard. Like this is the particular event that has been created with the particular payload that we have set that particular payload as well, right? So all the things is working fine. Now this is about the creating the command. The same way we can create the different commands for updating the data, deleting the data, and everything over here. Okay, so you can go ahead and try all those particular events and particular commands as well. Now the other thing that is important in the CQRS is the Q part, that is the query API. So let's go ahead and implement that query API to fetch the data from the stored data over here. So let's go ahead and do that. Ideally, you might be creating the different services altogether for your command part and the query part, but in this particular example, for the simplicity, let's create in the same way. Okay, in the same particular example. So instead of the command API, we have created this query API. So in this, we will be creating the different packages and different classes over here. So let me just stop the server over here, and the first thing that we will do, that is creating the controller. So let me just create the package over here that says controller, and let me create the class over here, that is the product query controller, and I will annotate with @REST controller, and I will add the request mapping as well, /products. Now public, I need the list of data, right, whatever we have stored over here. So I need the list of what product rest model, right? Now here you can see that I'm using this particular product rest model, that is the part of your command API. Okay, so ideally you should not use that way. You can create a core library for both of these that you can use in both the particular example. So we have the command API and the query API. You can create the core API where you can store all the common classes or the common packages over there, and you can utilize all the common files or call the common classes from there itself. But for now it's fine. So whenever you are implementing, make sure that you do that way so your project structure is very clean. And I will name the method as get all products, and I will annotate with @get mapping over here, and this should return the list over here. So for now let me just do return null, so there is no compilation error for now. Now here what we need to do, in the command API we created the command gateway to send our command, but for this particular query API we need a query gateway. So let me just create the object of it, just say private query gateway from the Axon framework, and I will use the constructor injection over here as well. Now you should understand all this. It's very easy. So in the command, you created the command, and in this particular query API, you will be creating the queries to fetch the data. Two different things, command and query. Command, you will be telling the system to do some commands, to do some operations, and the query means you will be creating the queries to fetch any data that there is a state already in the application where you will be having some data that you want to fetch. So this is the two difference that you will be creating, and for the command you will be having the aggregate, and for the queries you will be having the projections. Both are same, command handler and the query handler. Okay, you can name it either way. So here we'll be using the projections. Okay, so your controller is created. Now you need to create the query instead of command. So let's do that. So what I'll do, I'll just create one package over here, command and create new package, and inside the query.api I will just say queries package over here. Okay, and inside this particular queries package I will create one query, that is get products query. Now you can use find products query also. I'm using get products query, so anything is fine. So yeah, you can see that I'm just using the products over here. Now if you are getting the users, you can go for get users queries, get departments queries, whatever you want to do, you can do that way. So let's just create a simple query over here, and let's go to the controller. Let me create the object of it, get products query. Okay, now I want to use the query gateway to query this particular query, that is get products query. So what I'll do, I will say query gateway dot. So here you can see that there are a lot of different methods available, that is query, subscription query, scatter gather queries. So I'll be just using the simple query over here, where I will define the query, like which query particular it is. It's a get products query, so I'll define that query, and I will define what is my response type, in which particular format I want the data back. So I will define that. So this is my get product query, and I want to define the response type back. So I'll just say response types dot multiple instance of, as I want a list over here, I will define it's a multiple instance of, and what multiple instance of. So it's a product REST model, right? So I'll just define product REST model dot class over here. So it's simple thing. I am just passing this particular query to the query gateway, and I am defining what is my return type as well. I am defining my return type is the multiple instance of product REST model, that is I might have multiple instance, and I can define here as well list of product REST models equals to this, and as this is a completable feature, I will use the join method to wait until I get the data over here. I will return this. My query is created. Now I need to handle this query, right? So let's go ahead and create the projection to handle this query. So in the query API, let me just create the package over here that says projection, and I will create the class that will say product projection over here, and I will annotate this with @component. Now from here also, from this particular projection, you can handle this particular query, and you can create the event, and that event will send you the data. That also you can create, or from this particular projection you can directly pass the data back as well. So from here I will directly pass the data back. To get the data from the database, I need the product repository. So let me just create the object of it, that is the private product repository, and I will use the constructor injection. Now I need to handle the query over here. So what I'll do, I'll create the method public instead of void. What I'm doing, I need to pass the list of product REST model over here, right? I need to handle the query. So what is the query? Get product query. and I need to annotate this with @query handler. For the command you will be using the command handler, for the query you will be using the query handler. Now what I want over here is I want the list of data, right? So it's simple, I just say list of products equals to product repository dot find all. Okay, so this particular will return the list of products available, but what I want a list of product REST model. Okay, so I want to change it. So what I will do is list of product REST model equals to products dot stream dot map products to product REST model dot builder dot build product dot get quantity price product dot get price dot name product dot get name quantity price and name. That's it, right? Dot build dot collect collectors dot to list. Simple thing. What I'm doing, I have the list of products and I'm converting to the list of product REST model over here and return product REST models. Simple thing. Okay, there is nothing fancy thing that we have done over here, and it's the same flow that we have created over here. We created the controller that will handle the API request, that will be /products for the get method, and we created the query instead of a command, that is the get products query, and that particular query has been handled by the projection over here. Now let's run the application and let's see. And here you can see that my application started. Let's go to the Postman, and instead of the post request, let me just create the new get request over here. And here you can see that we got the data, that is one mango. If I add the oranges, price suppose 500 for the 50 quantity, okay, 10 per each. It is saved over here, and if I hit send again, I should be getting 2 records over here. Okay, so my get request is also working perfectly fine. So this way you can create the queries and commands differently for your command API and query API using the CQRS. Now one more thing, when we are working with the event driven architecture, handling the transactions and handling the exception is very important, right? Now currently what will happen is, I will give you an example. Let me just stop the server over here, and let me go to the command API and go to the events handler where we are handling this particular product created event. And at this particular point I am saving the data. So at this particular point my transaction should be committed, right? Because there is no error. But after that, if there is any error, suppose I am just throwing the error, throw new exception over here. Okay, exception occurred. So after this particular saving the data over here, I am throwing the exception. Okay, now what will happen to our application? Let's see that. So let me just start the server. Okay, my application server is started. Now let's go to the console password, and if I run the query, you can see that I have 2 records over here. Okay, now let me go to the Postman over here, go to the post method, and here you can see that I am storing the banana over here, okay, for 550 rupees. And if you see the code also, I have thrown the exception as well. Let me clear the console. Let's go to the Postman. Let's hit send over here, and here you can see that though we have added the exception, this is successful. And if you go to this particular console over here, here you can see that there is an exception as well that says exception occurred at this particular point. Okay, and if you go to this particular console as well, and if you run this, you can see that data has been stored as well, which is not I want, right? Because there is an exception, that particular transaction should be reverted back, right? So how to do that? Ideally, other than the events handler, wherever the particular exception is there, it will handle perfectly fine. But whenever there is an exception in the events, you need to propagate that particular exceptions to all the places from where that particular command has been created, that is the controller layer as well, right? So let's go ahead and handle that as well. So whenever there is an exception occurred when you are handling that particular event also, it should roll back that particular transaction. So let's go to the IntelliJ IDEA. Let's close the server and do that. So in this particular point, what we have to do is we have to implement the listener invocation error handler. So whenever there is an error in our event handler, we need to propagate that particular error. So let me just create one of the package over here, command, and I'll create the package. I'll say exception. Inside this particular exception, let me create one class. I'll say product service events error handler. Okay, this particular class implements listener invocation error handler over here. Let me implement the method as well. So this is the on error method, and from here I'll just do throw exception. So here you can see that this is handling our event messages. So whenever there is an exception in our events, we are just rethrowing that particular exception. Now we need to register this particular handler in our application. So let's go to the main class over here, that is the product service application. And so here we need to handle this or register that particular handler. So I'll just say public void configure, and we will inject event processing configurer, and I will auto wire it. And for this particular configurer dot register listener invocation error handler. Okay, and here you can see that it is taking the string and the function. So I will provide the string as product and new product service error handler. So this is the one that we have registered over here. Now we need to use this particular in our events handler. So let's go to the products events handler, and I'll define processing group over here. Now at this particular point, we can handle the different exceptions that has been occurred over here. So what I'll do, I'll just say public void handle exception, and I will annotate this with exception handler of the Axon framework, not the Spring framework. Okay, and from here I'll just throw this particular exception back. Now here you can do the loggers as well. Okay, you can implement the loggers and everything over here. For now I'm just doing this simply. Now let's run this and test it out. As you can see that my server is started. Okay, now let's go to the console over here. Let me just refresh it, and here you can see that I have only 3 records available. Okay, mango, orange, and banana. Now if I go to the postman over here, let me try to save apple. I don't have apple, right? So let me try to save apple over here, and let me just clear the console from here as well. Okay, and let me hit send over here, and here you can see that that particular apple is also not stored over here because we just handled the event. So currently we have not done anything to throw back the exception to the particular REST API. Okay, so this is just we are handling that particular exception. So whenever there is an exception, that particular transaction is been rolled back over here for now, but we can handle this particular exception to get that particular exception message to the user as well. First, let's understand what is Saga design pattern and why we need a Saga design pattern. As per the definition, what is Saga design pattern? So here you can see that Saga design pattern is a way to manage data consistency across the microservices in a distributed transaction scenarios. Now, what is a distributed transaction scenarios? So firstly, we need to understand about the monolith architecture and the microservice architecture. Now, the transaction which has been started in a monolith application will be single, right? Because considering one example, like if you are placing an order, so when you're placing an order, you will be adding a product, you will be adding your data in the order table, then you will be performing the payments, you will validate the payments. Once payment is done, you will ship that particular product, you will add the entry for shipping, and then you will complete that particular order. So all those things will be completed in one single transaction in a monolith architecture. But when it comes to microservice architecture, It's not the case, because for every different things we'll be having the different services. Like for order there will be different services, for handling payment there will be different services, for handling shipping there will be different services. And when you are doing the same example, placing the order, then your transaction would start at the order services, where you will be starting your order, you will be adding your products in your shipping cart, and after that particular order will call your payment services, right? And from that particular payment services, once the payment is successful, it will call the shipment services to add your data in your shipment tables. And after that, once the shipment is completed, it will again call your order services to complete your orders. So you can see that your particular transaction is spanned across the different microservices. So to handle that particular scenario, that your particular transaction is been across the different microservices, that is the distributed transaction, right? Because your transaction is not at one place, right? It has to be handled from the multiple places. Suppose, taking the same example, when you start the order, you started the order, you added your data in your order table, like this many products will be added to your order. After that, you go for the payment, right? And suppose there is any issue in the payment services and your payment was not successful. So what should happen is, you should not be saving any data for that particular payment as well, and whatever you did for your order as well, right? Because that particular thing also should be neglected. So there are multiple ways that can be handled, and there is one way, that is a Saga pattern. And in the Saga also there are two things. One is the choreography pattern and one is the orchestration pattern. In this particular video, we will understand more about the orchestration Saga. So it's simple thing. When you have a transaction that span across multiple services, and how to handle that particular transaction, we'll be using any of the design pattern of the microservices to handle those transactions. So don't worry about anything. I will tell you in detail about the Saga orchestration pattern in this particular video, how it particularly works, and we will implement that step by step for one of the particular scenario, that is the same, that is order services. I have seen multiple videos and multiple trainers using the same scenario, because that's the best one that will help you out to understand this particular thing. Now let's understand the Saga orchestration. So here in this particular slide, you can see that we have one API, okay, that is a post request that is doing the /order. So we are placing the order over here, and in the Saga orchestration pattern, there will be one orchestrator that will handle your entire Saga, that will handle everything that has been happening in your application. So I'm placing one order, so that is one scenario. So everything related to that particular order, all the steps included in that, will be handled by one orchestrator that I have defined here as a order Saga. So this particular thing in the microservices we are implementing using the event-driven architecture. So to learn more about the event-driven architecture and how event sourcing and everything works, I have included everything in the previous video as well, so you can check that out as well. To give you brief about it, event-driven architecture is, we will be creating events and commands for every operation that we are going to perform. So if I give you more example, let me take you to the event sourcing page that has been defined in the Axon. So you can see that Axon framework uses the event sourcing, and what event sourcing is. Here you can see there is a entire table over here, and it defines the different events happen for that particular order, right? Because when you are placing the order, it might happen, yeah, like you might be adding some products, you might be removing some products, you might be changing the quantity of your products, and many things happens, right? So all those particular things that you do, that will be different events that you are performing, and all those particular events will be stored in the event sourcing. So whenever we have to perform all those particular operations, then we can do that. We can replay all those particular events to identify what was the issue when that issue occurs, or we can also identify what the particular user or a customer has done for that particular order. And what will be the difference between event sourcing and the data that you are reading from the database is, event sourcing will include everything. Here you can see that there is a different event, like you selected the pizza, okay, then you selected the cola, okay, so, and after that you selected the ice cream as well, right, in the third event, and after that you remove the ice cream as well, okay, and then after that you added the order as well. So here you can see there are different events occurred. At the final was, you selected pizza and cola and you confirm the order, right, because you added the ice cream and then you removed the ice cream. But at the end, in your read table, what will be the data is, you added the cola, you added the pizza, and your order was done. There was no detail like you added the ice cream and you removed the ice cream. That we can get to know from the event sourcing. So this is the key concept, that event sourcing is been used by the Axon framework. So we will be using this, and we'll be also using the Axon server. So Axon server will be responsible for storing all those particular details, and we will be using Axon framework alongside the Spring Boot to handle all these particular operations. So this is all about the Axon server, Axon framework, and how we are going to store the data. Let's come back to the Saga orchestrator. So here you can see that there are different services available. So these are the different microservices that you have, that is order service, product service, payment service, shipment service, notification service, and all. And this is your orchestrator that will handle all those particular services and which particular services to be called for the different operations. So when you place a particular order, at that particular time, the orchestrator is creating a command like create order command. That means it is giving the command like I got the request to create the order and I'm giving you the order to create the order. So this is the particular create order command. So create order command will be consumed by the order services. This particular order service will have the command handler for that particular order. From that particular command handler, this particular command will be handled, and at that particular time all the validations and all those different things will be performed. And after that, once the validations and everything is performed, that particular order service will create the event. So that particular event would be order created event. At that particular time, order created event, this particular event will be consumed by this order Saga as well, plus your order service as well, right? Both the things will consume that particular event. What order service will do? Order service will store that particular order and it will say that I got the order. So that particular data will be stored in the database for order service. And this particular event is been consumed by this order Saga, and this particular order Saga will know that okay, I got this particular event. That means the order detail is been stored in the database. Now after that, I need to block that particular product. Okay, because suppose I have the quantity of 5 in my stock, and when one particular order has been done, I need to block that particular product, right? So it will create a new command to block that particular product. This particular command will be consumed by the product service, and that particular product service will remove the quantity from that particular table, and then it will create a new event, that is product blocked event. So order Saga will get to know, okay, this product is also blocked now. Now let's go to the next step, that is to validate the payment. So it will create a new command, that is validate payment command. This validate payment command will be consumed by the payment service. This payment service again in return create the event, that is payment processed event. This particular payment processed event will be again consumed by both order Saga plus payment service. Payment service will perform that particular payment processing, okay, and store the details in the database. And order Saga, once it consumes this particular payment process event, it will go to the next step to give the next command, that is to ship order command. So it will create a ship order command, and that particular ship order command will be consumed, will be handled by the shipment service, and this particular shipment service will create the particular event, that is order shipped event. And this particular ship order command, you can see that was consumed by the notification service as well. So notification service, what it will do is it will also consume that particular event, and it will notify the user, okay, we got your order and we will ship that particular order. Okay, and at that particular end, like order is shipped now, and at that particular time, that particular entire Saga will be completed. So until and unless that entire Saga has been completed, your order won't be processed. If there is any error, that particular entire transaction can be revoked. Now this was the happy scenario. Now let's understand how the transactions are. So you can see that the Saga transactions will be defined in this way. There will be multiple transactions available, and as it is span across the different microservices, you don't have that ability to revoke that particular transaction. So for all the transactions that you do in all the different microservices in that particular project, you have to have the compensating transaction to perform the revoking operation. So suppose you created the order, and after that you created the payment, and your particular payment service failed. So at that time you have to have the compensating transaction for your order as well. That order, whatever that you stored, has to be cancelled, right? So here you can see there is T1, T2, T3 up to Tn, and the compensating transaction should be C1, C2, C3 up to Cn-1. Now if you have gone up to the third step like T1, T2, T3 and something happened at this particular point, then for this particular point you should be having the 2 compensating transaction, because you are at the third place. That should be C of n-1 and C of n-2, that is C2 and C1. I will explain you in detail about all this particular thing, and we will be creating all this particular compensating transactions also in our tutorial, so don't worry about it. Just try to understand that there will be transactions and there will be compensating transactions for that, because we cannot handle the atomicity directly in the microservices, right? So now let's understand the flow, that what we are going to build and what are the different transactions and compensating transactions that we are going to see in our example. So here you can see that whenever that particular API will be called, there will be controller. That controller will handle that API request, that is post for the orders, post for the create orders, and it will create one particular command, my order saga. This is everything about my order saga. So this particular order saga will have one command, that is create order command. So once I have that particular command, there will be always a two scenarios, right? There is a positive scenario and there will be negative scenario, success and failure. So we will see both. So when there is a success from that particular command, okay, at that time we will create the order created event. So for every command we will be creating the event. So once that particular command is successful, we will create the event for it. And if it's not successful, we will create the compensating event for it. So this is a create order command, and if that is successful, order created event will be created. And if it's not successful, we will create the cancel order command over here to cancel that particular order. Now when we create the order created event, and that particular cancel order command will create the order cancelled event to cancel that particular order. Now if the scenario is successful and there was no issue in creating the order, after that we will create the new command, that is the validate payment command, to validate my payment for whatever the order that we have got. And for that, if every validations and everything is successful, we will create the event that is called payment processed event. And if it was a failure scenario, we will create the command, that is cancel payment command. Okay, and this particular cancel payment command will create the event that is called payment cancelled event. Now this particular payment cancelled event should call the cancel order command as well, because we need to have the compensating transaction for everything, right? So once my payment is cancelled, I need to cancel the order as well. So this particular payment cancelled event will again call the cancel order command, that will cancel the order for me. Now let's come back to the positive scenario, that is I have created the payment processed event when payment validation was successful. After that we will create a new command, that is ship order command. My payment is successful, now let's ship that particular product. And in that scenario as well, if it's successful, we will create a new event, that is order shipped event. And if it's not successful, we will create the new command, that is cancel shipment command. That again will create the event, that is shipment cancelled event. So there is issue in my shipment, right? So that shipment should again cancel my payment as well. So here you can see that shipment cancelled event is again calling the cancel payment command, that will again call the payment cancelled event, that will result in the cancellation of the order. Okay, so here you can see that there will be a chain of commands that will be executed, like the one that we saw, a list of transaction and a list of compensating transactions for it. Now let's get back to the success scenario. My ship order command was successful and that resulted in the order shipment event. So that particular order shipment event will result in the complete order command. That means my order will be completed at that particular time. My saga should also be completed. So here you can see that complete order command is successful. It will result in the order completed event. And once the order completed event, it can send the command like send invoice command to send the invoice. And when the order cancel event was executed, okay, at the time also we need to notify the user like your cancellation was done for your particular order because of this particular issue. So at that time we'll also send the alert cancellation command to the system to send that particular cancellation to the user. So here you can see that we have the success scenarios and we have the failure scenarios as well, and you can see everything is linked together. For every particular point wherever you are, we will be creating a compensating transactions for it. So try to remember this particular picture, try to get a screenshot of it, and whenever we are implementing, you can refer to this particular diagram. Now this is all about the theoretical part. Now let's start our application. So what we will do, we will create all the different services. If you have seen over here, you can see that I have mentioned order service, product service, payment service, shipment service and notification service. We will be creating all those different services over here, all the different Spring Boot application. And in all those particular Spring Boot application, we will use the Axon framework. So let's directly jump into it. Okay, so let me just go to the Spring Initializer. Let's add the details over here. So for the group, I will add com.daily code buffer. Artifact I will give as order service Okay, packaging would be jar, Java version is 11, and let's add the dependencies. I will add this Spring Web dependency. I will add the Lombok dependency for creating all the boilerplate codes. Then I will add the Spring Data JPA dependency, and I will be storing all my data in the H2 database for now. You can use the MySQL or any of the database. So I think this should be fine, and once we download this particular project, we will be adding our Axon framework dependencies as well. Okay, so let's generate the project, and here you can see that the Spring Boot version is 2.5.5. Okay, so now let's generate this particular project and open in IntelliJ IDEA. So here you can see that I have just added the order service in IntelliJ IDEA and it's resolving the dependency. So we'll wait for a couple of seconds to complete that. Meanwhile, let's go to the Google Chrome. Let's go to the Axon server page. Go to the axoniq.io/product overview/Axon server, and you can download this particular Axon server. I will just add the link in the description below so you can directly download it. Just download this particular server. Okay, I have already downloaded, so I'll just show you that. I'll just go to the downloads one, and here you can see that this is the Axon server. So let's unzip it, and for this let's open the terminal, and let me go to the downloads. Okay, and here you can see that in this particular folder there is Axon server.jar. So we'll be running this particular jar file. So let me just start java-jar Axon server.jar file over here. Okay, and here you can see that your Axon server is started. Okay, so let's go to the Axon server over here. It is running on port 8024 over here. Okay, so let's go to the localhost 8024, and here you can see that this is your Axon server dashboard, and here you can see all those particular details, the overview, but there is no application connected to it. Okay, you can search all the different events that has been occurred. I'll just enable the live updates, so whatever the events occur, it will come over here. Whatever the different commands, you can see the commands over here. What are the different queries, you can see over here. So we'll be using CQRS pattern alongside Saga, so it will be useful for you. If you have seen a previous video, it will help you a lot in this particular video. So this is the Axon server for you. Now let's get back to the IntelliJ IDEA. This is your order service. Let's go to the pom.xml file, and here we need to add the Axon framework and the dependencies for it. So let's go to the browser and let's search for Axon framework Spring Boot starter for Maven repositories. Okay, Spring Boot starter module for Axon framework, and the latest one, let me check which is the latest one, 4.5.4, right? So let's take this one, copy this and add in the dependency section over here. And alongside with this, we need to add the Google Guava dependency as well. So let's go. So let's add the Google Guava as well. Okay, I will just add the 31.0.1 GRE version. So let's copy this and add over here. So these are the two dependencies that you need to add in your application. Okay, let it resolve it. Okay, it's resolved now. Now let's work on our application. Now as we added the order service, let's add the user service, shipment service, notification service and payment service. Okay, so let's go back to the browser over here. Let's go back to the Spring Initializer and let's change the details. Instead of order service, I will just say user service. Rest all the details should be same. Generate the project. Let's add the payment service as well. Generate the project. Let's add the shipment service as well to handle the shipments. Okay, this is a shipment service. Generate the project. Now one thing is, as we are having the multiple services, there might be some files, some classes that you will be creating that will be used in multiple services, right? So for those particular things, we'll be creating one common services, and the dependency for that will add in every resources, every services that we have, so there is no duplication of files. Okay, so for that, let me create the common service. Okay, so all the common files, common classes we will keep here, and we will add the dependency in all the projects. So this is the common service, and in this particular common service I don't need H2, I don't need JPA, I don't need web as well, just the Lombok dependencies to add the getter setters and all the boilerplate codes. So let's generate the project as well, and now let's open everything in IntelliJ IDEA. So let me first go to the Finder, user service, payment service, shipment service, and common service. Okay, let's go to the IntelliJ IDEA. Let's add all the modules over here. Go to the downloads. Let's add the common service, add the payment service, add the shipment service over here, and add the user service as well over here. Now you can see all the projects are here. Now I need to add this particular dependency in all those particular projects. Okay, so let me just copy it, and let's go to the payment service. We'll go to the pom.xml file, we'll go to the dependency and add this. Let's go to the shipment service again. Let's go to the pom.xml file, and let's add the dependency for that as well. And let's go to the user service, pom.xml file, and let's add the. Okay, so I've just added the Axon framework dependency and Google Guava dependency that has been needed for the Axon framework in all the particular project. Now if you go to the common service over here, if you go to the main Java, I don't need the main class as well, so let me just delete that as well. Okay, and let me just copy these details, that is group ID, artifact ID, and version over here, and let's add this particular dependency, common service dependency, in all the projects. So let's go to the pom.xml file, let's add the dependency. Okay, so I just added the coordinates for that particular common service over here. Now let's copy this and add in all the projects. So this was in the order service, right? So let's go to the payment service, go to the pom.xml file and add this dependency. Orders payment service is done. Now let's go to the shipment service, add the dependency for the common service over here as well, and in the user service as well. Done. All the configurations are done now. Now what we need to do is we need to configure the database as well and the server ports. All these particular microservices will be running on the different ports, and all those particular microservices will be having their own database, right? So, and as we are using the H2 database, I'll be using the file database over here. Okay, you can use the MySQL as well, there won't be any change. So let me just go ahead and add all those particular details as well. So let's go to the order service, go to the src main resources, and go to the application.properties file. So let me just copy the details over here to save the time, and I will explain you the details. So here you can see that I just added the details in the order service application.properties file, and that is server.port equals to 9091. So my order service will be running on port 9091, and here you can see that these are the details for my database. So spring.database.url I have just provided. I'm using the H2 file over here, and this is /data/orderdb. So in my data folder, in my local orderdb file, orderdb database will be created, and the driver class name I provided is H2 driver, as I'm using the H2 database, the username and password for my database, and the dialect I'm using. I've just enabled the console over here, so I can go to the H2 console from the browser, and I've added the GPA configuration for DDL auto equals to update. So whenever I do any changes in my entities, it will be automatically updated. So these are the same settings that will be adding in all the different applications. So let's go ahead and do that. I've just added for order. Let's add for payment over here. Let's go to the payment src main resources application.properties, and I've just added the details. And this particular payment service will be running on port 9093, and the database is paymentdb. Rest all the details are same. Okay, now let's add for the shipment service as well. Let's go to the src main resources application.properties, and these are the details. Shipment service will be running on port 9094, and the database is shipmentdb over here. Let's add for the user service as well. So in the user application.properties, I'm just adding that my application should be running on port 9092. So from this particular user service, for now I'm just planning to pass the static information, so I'm not adding the database for now. But you can go ahead and add the database details, and you can get the details from the database to pass on. To shorten the tutorial length, I'm just doing this static for now for only user service. Okay, now I've added all the details over here. Now in this particular order service, what we will do is we will just create the different packages for now, and we will start implementing our project. Okay, so let me just create the package over here, and I'll just say command.api. So all the different commands will be adding in the commands.api. I will also create the queries.api to add all the different queries. Commands and the queries are the thing that you can learn in the CQRS video. And one more I will just add is a query.api. And in this particular command.api, let me just add the other package, that is command.api.controller. I will just create the controller over here. And let me add one more package for the different models that we are going to create. Okay, so let's create the controller first, and here I will just create a Java class, and I will create a controller order command controller. Okay, so this particular controller will handle the post request for creating the order. Okay, so what I'll do, I'll just annotate with REST controller, and I'll also do request mapping over here /orders. Now in this particular controller, we'll be creating one method to handle the /order post request. Okay, so let me just create a method, public string create order, and I'll just return order created. And whenever we want to create an order, we will be creating one JSON body over here, right? Like what will be the order details, like order ID, the price and everything. So for that, let's create a model for it, and let's inject it over here. So what I'll do, I'll just, in this particular model package, I will create that particular file. So here in this model, let me just create Java class order REST model over here. And here I will say private string product ID, private string user ID for which user this order belongs to, private string address ID to which particular address that I need to send this, and private integer quantity, how many quantity of this particular product I need to send. And for this order REST model, let me use the Lombok to add all the getter setters, constructors and no constructors. Okay, so I'll just say @data all args constructor for all argument constructor @no args constructor, and I will inject this order REST model in my order command controller. So I'll just say order REST model, and this should be my request body. Now from here, what we need to do is we need to create the commands, and we need to create the events to handle this particular thing. So if you go to the particular slide over here, you can see that we have created the different commands, and we will be creating the different events to handle those particular thing. Okay, and if you want to understand the flow, this is the particular flow, right? So for the products, in the previous video, what we did is we added the particular API, and that particular controller was handling this /products for the post mapping over here, and this particular controller was creating the command, that is create product command, and sending to the command gateway. Here what we will be doing is create order command, and this particular command will be sent from the command gateway, and there will be one command handler. We can also call that command handler as an aggregate. So this particular aggregate will be handling that particular command, that is create product command. In our case, that's the create order command, and it will handle that particular command, and it will create the event. So the event would be order created event instead of product created event, and all those particular events will be stored in the event store over here, and there will be one event handler that will be handling those particular events, and it will save the data to the repository. But in our Saga, there will be one more Saga that will be handling that event, and based on that event, it will call the other command as well. Okay, so here you can see once that particular event is created, so that particular event is been handled by this particular order Saga, and it will be processed by the different services that we have. In this particular slide, you can see that we will be creating create order command over here and order created event over here, and this will be handled by the Saga as well plus my order service as well. So let's go ahead and do that. Let me just go to the IntelliJ IDEA again, and here we need to create the commands. Okay, so let me create the command. For creating the command, I will just create one more package over here, and I will say command, and in this particular command package I'll create the class that is create order command. And as I told you in the earlier video as well, all these particular commands and all the events that we create over here, all those particular classes, all those particular objects should hold the data over here, right? So whatever the data we are sending from our controller, it should hold all the particular data. So then only at the end it will be able to receive that particular data and update all those particular data. So whatever the payload, right, this is a command, and this command should have the payload, like what data or what I need to process. So we will be adding all these particular properties that we want to store, and we will set all those particular properties. So here what I need is, let me go to the order rest model, and I need all these particular properties. Okay, plus what I need the order ID as well. So this many things I need. Now for all the commands and all the handlers that we create, right, it has to have a unique identifier. So in the previous video also I explained you about that. So here this particular order ID will be the unique key, right, for me. So I need to annotate with target aggregate identifier. So this particular ID will be handled by the aggregate. So aggregate will be able to understand the difference between the different orders that it has to process, right? So that will be based on this particular order ID and this particular annotation. So this is the target, and that particular aggregate will contain the aggregate identifier with the same field. So let me just annotate this particular with data and builder annotation, so we can use the builder pattern to populate all the fields. Now the command is also created. Now we need to handle this particular command. Before that, let me add one more field that I will be needing. I just forgot to add. That will be the order status. Right? We need to understand like what happened to this particular order. Order created, cancelled, and approved and everything, right? So for that, I will maintain the status field over here. And to handle this particular command, let's create the command handler, or we can say that as an aggregate. So for that, let's create one package over here. Create a package, and I'll say as a aggregate. Here I will create one Java class, and I'll say as an order aggregate. Okay. All the aggregates that you create has to be annotated with aggregate annotation, and all this particular aggregate should also have the fields that you have in the command. So let me just copy this, and let's go to the order aggregate and paste this particular fields over here. And in the command you have defined as a target aggregate identifier. Here you will define order ID as the aggregate identifier. Okay, so your aggregate is created. Now you need to handle this particular command. Okay, the command is create order command over here. So till now we have not created any Saga. Okay, this is not a Saga, this is just simple event processing that we are doing. We will create a Saga for it. So let's first complete this particular part. Now in the order aggregate, we need to create the constructor. So let me create the constructor for it. It is a default constructor, and I will add one more constructor, and this particular constructor will take the create order command as the input parameter. Create order command. So this particular part is necessary to register a particular command. Okay, and now here we'll handle this particular command. And one more thing to understand over here is, for all the aggregates we are handling the events over here, right? So we are storing all the data as the event sources, right? What you saw in the event sourcing over here. So here you can see whatever we saw over here, correct? at this particular part, right? So here you can see that event sourcing. So here selected pizza is there. After that you selected cola. So at that particular point you can see that pizza is also there. So the previous event plus the current event, all the data is been stored over here, right? So for that, how a particular aggregate will come to know is we need to handle this event sourcing over here as well. So we will add the event sourcing handler as well, that will handle all those particular events. What we will do in that particular point is we will update the data. So whatever the fields that we have defined, okay, so for all the different events that we do, whatever the fields are getting updated, we will update that particular fields to update the states of the event. So first let's handle this particular command over here. So this particular command, that is order created command, will create a new event, right? Because a command and event will go hand to hand. So this particular create order command has to create an event that will be order created event, right? So let's go ahead and create the event as well. The event, for that what I'll do, I'll just create the new package over here. I'll say events, and in this particular events package I'll create a class order created event. Okay, so this is also the event, and this event should have the payload data. So what I'll do, I will go to the create order command. I will pick all the fields over here, go to the event order created event, and I will add the details over here. Okay, so this is the same payload that I want, and I will annotate this particular class as data for our getter setters and default constructors. So for my command, let's go back to the command handler, that is our order aggregate, and here we should create that event. So I'll just create the object of that event, that is order created event equals to new order created event. And what I want to copy all the status, right, all the state of this particular command to the event, all the payload data. So what I'll do, I just use the bin utils dot copy properties method. This will take the create order command, and I'll just give order created event over here. So it is just copying the data from here, and here I need to apply this particular event. So what I'll do, I'll just do aggregate lifecycle dot apply. What I need to apply, you can see that was a payload. So my payload would be event, that is order created event. So here the event will be handled now. But if you go to the controller over here, from this particular controller we did nothing, right? So from here we need to publish this particular command to the command gateway, then only our aggregate will be able to handle that. So let's do that. Here we will be needing the command gateway over here. So let's create the object for it. What I'll do, I'll just say private command gateway, part of the Axon framework, and command gateway over here. Okay, and let me use the constructor parameter. Okay, add constructor parameter over here. I've just added the constructor that will initialize this particular command gateway. And what I'll do, I need to get the data from this particular REST model, and I need to populate the command. So let me just do string order id equals to uuid dot random uuid dot to string over here, and let me create the command. So the command is create order command equals to create order command dot builder dot build, and let's add all the details. I'll just say order id equals to order id dot address id from the order REST model, right? Order REST model dot get address id dot product id, order REST model dot get product id dot quantity, order REST model dot get quantity dot order status, and this will be created. Okay, the object is created. Now I need to send this particular command. So what I'll do, I'll just say command gateway dot send and wait create order command. Simple thing should be get, right? This is very simple. Whatever the data that we were getting over here, we populated all those particular details in the command, and that particular command we send via command gateway. So this particular command will be handled by the order aggregate over here. We can see we have injected this particular command, and here what we need to do is we need to validate this particular command. Okay, what type of validation, like whatever the details that we got are correct or not, all those particular validations, the business logic and everything you can validate over here. And once the validation is successful, you can create this particular event. What I did, we created the event, that is order created event. We created the class for it, and we populated all the values over here, populated the payload, and we apply the event in the aggregate lifecycle. That means we send the data to the Axon server. Now I need to annotate this particular with the command handler, okay, because we are handling a command over here. And let's go to the controller, and this is our post mapping, right? Let's go back to the aggregate. Now, as I told you, right, we have to handle the event sourcing as well. So whenever the event you're creating, you need to handle that as well. So let's handle that as well over here. So whatever the data that you are adding in the event, that has to be updated in my aggregate as well. So what I'll do, I'll just say public void on what? Order created event. Okay, so we are handling this particular event, we are injecting it over here, and I need to annotate with event sourcing handler. Okay, and whatever the values are there in this particular event, we need to update to our aggregate. So let's do that. I'll just do this dot order status equals to event dot get order status, this dot user ID equals to event dot get user ID, this dot order ID equals to event dot get order ID, this dot quantity equals to event dot get quantity, and this dot product ID equals to event dot get product ID. Hope everything is there. Our address ID is missing, right? So this dot address ID equals to event dot get address ID. Okay, so I have handled the event sourcing as well. So whatever the event is created, that particular data I'm updating in my aggregate as well. So this is my first event that I have created. Now based on this particular event, I need to handle a series of commands and events over here, right? So this is a perfect place to start our Saga, and we will be creating the Saga in a service which will be starting the starting event over here, or the starting command over here. Okay, so in this particular case, that's the create order one. So we'll be creating the Saga in this particular service. So to create the Saga, let me just create the package over here, and I'll just say as a Saga, and in this particular package, let me create the class, and I'll say as a order processing Saga. Now in this particular Saga, there are different things that you need to take care. That is, the first one is to annotate with @Saga over here. Okay, so this will be behaved as a Saga, and after this, every event will be either starting the Saga or ending the Saga. So you should be having the start Saga annotation or the end Saga annotation in either of the events. Okay, because there has to be a start Saga and there has to be the end Saga. You can do by the annotation as well, and you can do by the programmatically as well. But you need to make sure that you start the Saga and end the Saga, and all the events that you handle has to be annotated with @Saga event handler, because this particular events are the Saga events, right? And because this particular event, right, if you see create order event, this is the particular event. So to handle this particular event, you will be using the event handler annotation and to store the data. Okay, that we will do in a second. But when you are handling the same event in your Saga, you need to annotate with @Saga event handler. So this is the Saga that we have just created. Okay, let me annotate with @SLF4J as well, so we will get the loggers. So this is just a basic thing over here. Now before we do anything in the Saga, let's just go ahead and complete one single event, that is the order created event, and let's store the data. Okay, so what we'll do, we will create the event handler that we will complete that particular event, and Saga will handle that as a Saga event. Okay, so let me just create let me just go to the events. Let me just create the class that says order events handler, and let me annotate with @component, so it's in the Springs radar. Now this particular events handler should handle the event that was created from this particular aggregate, that was order created event, and whatever the data it has to store in the database. So let's go to the event handler and let's create the method public void on order created event. Okay, and this I will be using as the event handler, part of the Axon framework. Now here what I need to do is I need to handle this event. That means I need to store the data. So for this, what I need the entity and I need the repository as well. So let's go ahead and do that. Let me just create the package over here that says data, because we are handling the data over here. And in this particular package, I will just create the entity and the repository. So let me just create a Java class that says order. And here what I need all this particular fields over here, that is order ID, product ID, user ID, address ID, quantity, and order status, whatever were there in the events. What I'll do, I'll just annotate with @data, and I'll also annotate with @entity over here. So this will be behaved as your entity, and you need to have one primary key. So I will just annotate my order ID as the @ID, and I'll also annotate with table to give the name of the table, and I'll say orders over here. So this is my entity. This is nothing new. This is part of the JPA. I have created a dedicated course for the Spring Data JPA. You can go ahead and check that out as well. So to handle this order entity now, we need to have the repository. So let's go ahead and create the order repository. I'll just create the new interface over here. It should be the interface, and it should say order repository. Okay. And this particular order repository will extends JPA repository. And this particular JPA repository is of type order, and the ID is of type string. Now let's go back to the order events handler, and here I need to store the data. So for here I need the object of the order repository. So let's do that. I'll just do private order repository. And let me add the constructor for this. Now I need to create the object of the order as well to save the data. So what I'll do, order equals to new order over here, created the object, and I'm just using beanutils dot copy properties from event to order, and I will just say order repository dot save order. Simple, right? We just handle the order created event using the @event handler annotation to save the data. Now I need to handle the same event from the Saga as well, because this particular same event will create the series of the other commands and events as well. So let's go ahead and do that. We'll go to the order processing Saga, and here we need to handle the same event. Private void handle order created event, and this should be @Saga event handler, and all this particular Saga event handler should have the association property to associate with. Ideally you should give the whatever your primary key should be, right? For whatever the unique value should be. For us it is order ID, so I'm just giving the order ID over here. Now this particular event, the first event, that is order created event, is the starting point to start our Saga. So I will just annotate with start Saga. So this particular will start the Saga. For this particular Saga, right? So whenever you are working with Saga, all this particular data will be stored in your database as well. So what will be the Saga ID and all those different things you will see in the database. I will just show you like what are the fields are there and how it is storing the data as well. From that only it will able to understand how to handle all these particular different events that we are creating. Now let me just log it for now so we can see in the logs. So log.info, I'll just say order created event in Saga for order ID event.getOrderID. So we'll get to know like the order created event was executed in the Saga for a particular order ID. Now this particular event should trigger some of the other commands, right? So if you go to the browser over here, let me go to the particular slide, and here you can see that order created event from the Saga should trigger validate payment command. So we need to have this particular validate payment command created, update all the values that we have to update the payload. So we will update the payload and we will send this particular command via command gateway. So any of the other command handler can handle this particular command and create a new event. It's just a series of commands and events that has been tied together to handle the entire operation. Nothing fancy, it's very easy. Once you get a hang of it, once you see the entire example, you will get a lot more clear understanding about a Saga design pattern. This first Saga event handler should be creating the event that is the validate payment, whatever we saw, validate payment command. So let's go ahead and create that. Now this particular validate payment command has to be used in this particular order service as well, because we are having this particular order processing Saga over here, and that particular payment has to be handled in the payment service as well, right? As it's in the multiple places, we will keep that particular command in our common service. So let's go to the common service and let's create the package, and I'll say commands, and in this particular commands I will create a command that is validate payment command. So this we can use in the multiple places, as we have added the dependency for this common service in all the projects. So this is the command that we have created. Now for this particular command, what is the payload that we require? You need to identify that, and we need to add all the particular fields, and we need to update it accordingly from the event handler. So let's go ahead and check that. Okay, so for this what I will be needing is private string payment ID, unique identifier for it, private string order ID for it, for which particular order the payment is, and I need the details of the payment as well, right? Like how the payment has been going to happen. For now I'm assuming that it's going to be via credit card or a debit card. So I will just create a one particular model that will be having all the card details. So let me just do that. Private, I can say card details. So let me first create the model for it. So what I'll do, I'll just create a new package. Instead of commands, I can say model, and inside this particular model I can say new class as a card detail, and this command should have that card details. Simple, right? So I'm having my payment ID, order ID, and the card details from which that particular payment should happen, and I'll annotate this with @data and @builder pattern. Now let's add the details in the card details as well. So what details would be having for the card is private string name, private string card number, private string valid until month, right? Till which month, and private string valid until year, so which year that your card is valid, and you should have a CVV as well, right? Integer CVV. Let me just change all this to integer as well, because this will be the integer values only, right? Okay, now this also I need to annotate with data and builder. Okay, for my get asserters and builder pattern. Now I need to create this particular command from the order Saga. So let's go back to the order processing Saga, and here I need to create the command. So that is validate payment command equals to validate payment command dot builder dot build. This command that you need to send. Now this particular command needs few details, right? Because this is the payload, right? This payload requires the payment ID, order ID, and the card details. Okay, so this particular details should be already saved in your user profile, right? So we need to get all the details from the user service. So we need to have the query created for it and to fetch the details for it, and then only we will be able to store all the details, right? So let's go ahead and do that as well. So before we set anything in the validate payment command, before we send this particular command, we need to create a query, gather details from the query and update over here. So for that, in the order Saga itself, we will do that. Okay, it's not advisable, it should always be a different one, but for the sake of understanding and the simplicity, let me just explain you over here as well. So to set all the details over here, we need to get all the details based on the user ID that we provide. Based on that particular user ID, what are the card details and the payment ID for it. So we need to create a query, and that query should be handled by the user service that we have. So what I need to do is, as this will also be the common query, let's go ahead and create in the common service over here. As we created the commands, let me create new package that says queries. And in this particular queries, let me create the new Java class and say get user payment details query. Okay. Now this particular query and command, you will get to know more about this in the CQRS video. Command is to do some operation, to do some operation, and query is to fetch the data that is been already saved in your database or whatever that you are using. Query will also have the payload details. Okay. So what payload that I want to send is user ID. So that is private string user ID. And this should also have @data @builder. It's only one thing. So rather than builder, I can just say @allargs constructor. So it will have one constructor with one field and should also have the no-arg constructor as well, right? So just one query I created with one field user ID. So once I pass user ID, I need to get back the details of the user payment and that particular object. So let's do that. I know you might be confused at this particular point, like what we are doing, like there is a lot of code that we are doing, but stick with it. Try to replicate whatever I am doing, and at the end, I'm sure you will get to know about everything what we did. So my suggestion is don't skip on it. Just try whatever I am doing. Just try to replicate it. Try to understand it. And if you have any question, ping me in the description below. I will try to help you out as soon as possible. Now let's move on. Let's do the handling of this particular query. Okay. Now this particular query has to be handled by the user service. So let's go to the user service. Okay. This is my user service. And in this particular user service, as this is the query, I need to have the query handler, right? Not the command handler. And the query handler can also be known as the projection. So let's create the projection for it. I'll just create the package and I'll say projection, and I will create the class that says user projection, and let me annotate with @component. Now from this particular point, we need to send the entire object back of a user, right? So we need to create the model. So that particular user should have the details like the user ID which I'm passing, right? So for that particular user ID, I need to pass all the details, that is first name, last name, and the card details that we want. So for that, we need to create a model, and as that particular model has been used by this particular user service and the order service, we will create in the common service. So let's go over to the common service. In the models, let's create one Java class and that says user, and this user will have private string user ID, private string first name, private string last name, and private card details. Okay, and let me annotate with @data and @builder pattern. Okay, so this is my model created. Now I can return this model from my user service. So let me go back to the user projection over here, and here let me handle that particular query. So what I can do, I can just say public, what I need to pass back is the user, and get user payment details. What is the query that I need to handle is get user payment details query and need to annotate with @query handler. So from here I need to pass the data. So let me create the object of a user and pass the details. Let me just add the card details first. Card details equals to card details.builder.build dot name equals to Daudi dot valid until year 2022 dot valid until month 01 dot card number I'll say 1 2 3 4 5 6 7 8 9 whatever, and I need to add the CVV also, right? Dot CVV equals to 111. Guys, this is a dummy card. Okay, so this is the card details. Now I need to return this, right? So I'll just say return user dot builder dot build dot user ID should be query dot get user ID dot first name is Shabir dot last name is Daudi dot card details is card details over here, and finally done. So I'm just returning the user details over here. This is a static details I'm passing from here, okay, to save the time, but ideally based on this particular user ID that we get over here from this particular query, we need to get the data from the database and we can send the data. I can mention this over here as well, so whenever you are referring you'll get to know. Ideally get the details from the DB. So this particular user details we will get in the order saga. So let's go to the order saga and we need to get the details over here and set the values. So we'll just say get user payment details query equals to new get user payment details query, and in this I need to pass event.user ID. So this is the query. Now I need to send this particular query and get the data back, and here let me just create the user object, okay, and I'll just say user equals to, now here I need to have the query gateway, okay, to send this particular command. So let me just create the object of it, and let me create the object of the command gateway as well. So whenever we need, we will use from here. So what I'll do, I'll just say private command gateway, and I'll say private query gateway, sorry, not query handler, query gateway. Okay, now for both of this, let me do the constructor injection and I will do auto wire. This is very simple thing, just the injection of the two objects that we have, that is command gateway and query gateway. So here we need to use the query gateway. So I'll just use query gateway dot query. Okay, there are a lot of different methods. I will just use the query method over here. What I need to query, get user payments details query, and what I need back in the response, that is response types dot instance of. As I am getting the single instance, I'll just use the single instance of, and I'll just say it's user dot class. And as this is the completable future object, I need to wait until I get the data, so I'll just use join over here. I just created the query over here and I've just passed the query using the query gateway, and we are just waiting to get the details back over here, okay, because these details are very necessary for our next command. So we are waiting. There might be two chances, like we are getting the details from the user service or we are not getting the details. So at this particular point we need to handle that particular exceptions as well, right? If we are getting the details, then only we will be able to pass the details in this particular validate payment command and we can proceed ahead. Otherwise we need to cancel the order as well, right? So let me just do try catch over here. So whatever this particular thing is there, let me add inside, and if there is any error, I'm just doing log.error e.get message, and if there is any error, we can do the start the compensating transaction. Okay, this particular part we will come later, but if there is any error, we need to start the compensating transaction from here as well. Now, assuming user is not null and we got the details over here, we need to set all the values in the validate payment command, because we are still stuck at this particular command. We have not done anything yet. We were just doing to get the values. So now let's set this particular values. Okay. So what are the values? Card details we got. We'll get from the user dot get card details dot order ID, right? Order ID we will get from this particular event. So we'll just use event.get order ID dot payment ID, and this particular payment ID will be new payment ID, that is uid dot get random ID dot toString. Now validate payment command we have created. Now what I need to do is I need to send this particular command. So I'll just use command gateway dot send and wait validate payment command. Now I have sent this particular command to the command gateway. Now if you see this particular slide, validate payment command. Okay, now we send this particular command to the command gateway. Now we need to handle this particular command from the command handler, and we need to create the event, or either we need to create the compensating event as well. So let's go with the positive scenario. If validate payment command is successful, we are handling, everything is valid, then we can create the payment processed event, and all this particular thing we need to handle in the payment service. Okay, so let's go ahead and do that. So let's go back, let's go to the payment service over here. This is the payment service. Okay, here also let's create the packages. So I'll just create the package command.api, and as this is the command, I need to handle this particular command, so we need to create the aggregate as well, and there will be events as well, plus we will create the package for handling the data, that is entity and repository, because we need to save this payment details as well. So these are the three packages that we have created. Now to handle this validate payment command, in the payment let's create the payment aggregate. So Java class, and let's say it's a payment aggregate. Aggregate is your command handler. Okay, annotate with aggregate. If you go back to the validate payment command, your payment ID should be your target identifier, right? Because that will be your unique thing. So let me just annotate with target. Okay, sorry. So here as well I need to add the Axon dependency, because in this common service I just forgot to add. So let's add the Axon framework dependencies as well for here. Okay, let's go to the common service pom.xml file and add the Axon framework dependency. Reload the Maven project, go back to validate payment command, and we should be getting target aggregate identifier. Okay, so yeah, we are good now. Now let's go to the aggregate, that is payment aggregate over here. We annotated with the aggregate over here, and we need to have all these particular fields. Let me just copy this. Let me go to the payment aggregate and payment ID, order ID, and what is the status of that particular payment. So that also let me just store. Okay, and your payment ID would be your aggregate identifier. Now the same way what we did in the order aggregate, we need to do over here. We need to have a constructor, and the constructor that is injecting that particular command. So let me just do that. I'll just create the constructor, and let me copy this, and let me inject validate payment command. Okay, and this particular would be your command handler, and here validate the payment details, and if everything is successful, publish the payment processed event. Okay, this is what we have to do it over here. Validate the payment details and publish the payment processed event. So whatever the validation that we want to do on this particular command, we have the payload, right? So on that particular payload, we can do all the particular validation, like values are there or not, values are matching in the database or not, everything you can do over here. And once everything is successful, you can publish the event. I'm just skipping this part because I don't need it now. Okay, but if you want, you can do it over here. Okay, and in this particular point, let me just add the loggers over here, and I can just say log.info, and I can say executing validate payment command for order ID and payment ID, whatever it is. Okay, so let me just give those details as well. I can just say validate payment command dot get order ID and validate payment command dot get payment ID. Okay, so I'm just logging the details out over here, so we can get to know what's happening in the system. Now, as this part is done, we need to publish the event. So we need to create the event. So let's go ahead and create the event, as it has been used at 2 places. So we'll go ahead and create in the common service. So let's go ahead and create the events. So let me just go to the common service. We have commands, models, queries. So let's go ahead and create the new package. Events, and here I'll create the new event, payment processed event. Cool, right? And this event will have private string payment ID and private string order ID. And let me just annotate with @data @all-args constructor and @no-args constructor. Simple, right? Simple event that we have created. Now this particular event has to be handled at 2 places, right? We need to handle this particular event and store the data in the database in the payment service itself, and this particular event will be the trigger point for the next event that we need to handle in our order processing Saga. Okay, always 2 things. So if you go to this particular thing, you can understand from here, payment process event will again trigger the ship order command. So this has to be handled by this particular Saga as well as a Saga event handler, and in the same particular service as well to handle that event and store the data in the database. So let's go back. Let's go to the aggregate, that is your command handler, and here I need to get all the values from this particular command, populate all the things in your event and publish that event. So what I'll do, I'll just say payment processed event equals to new payment processed event, payment ID and get order ID. So this is the object. Okay, I just passed the 2 values in the constructor and the object of payment process event is created. Now we need to apply that event in the aggregate lifecycle dot apply the payload. What is the payload? That is payment processed event, and I can say log.info applied. Okay, so that's the simple thing, right? This particular payment aggregate is handling this particular command, validating the command. I'm just logging the information over here, and we are creating the event, that is payment processed event, updating all the fields over here and applying the event sourcing will happen. Now we need to handle the event sourcing as well to populate these fields that we have added in the aggregate. So let's do that. We'll just do public void on, and we need to inject the same event, that is payment processed event and event sourcing handler, and we need to update the fields. This dot payment ID equals to event dot get payment ID, and this dot order ID equals to event dot get order ID. So we just handle the command and publish the event. Now handle the same event in the same service and also handle the same event in the order Saga. So let's just first complete over here in this particular events in the payment service. Okay, this is the payment service. Inside this events package, let's create the class and say payments event handler. Let me just rename, it should be E capital. Okay, so it's more readable, and I'll annotate with the component, and we need to handle the event, that is public void on payment processed event, and I'll annotate with event handler. Make sure use the event handler part of the X1 framework. Okay, now at this particular point I need to save the details, so I need to have the payment entity as well and a payment repository as well. So I need to create that as well. Okay, so let me create that. In the data I'll just say payment, and here let me just add the details over here. Private string payment ID, private string order ID, date, I can say timestamp, and I can say the private string payment status as well. What is the status of the payment? And let me annotate with the data, and also let me annotate with entity to make it as an entity. And this entity should also have the primary key, that is @ID. Cool, right? Now this should have the repository. So let's create the repository, payment repository. Interface payment repository. Extends JPA repository, and the type is payment, and the ID type is string. And this particular repository I need to use in the payments event handler, because at this particular point I'm saving the data. So let me create the object over here, private payment repository, and I will use the constructor injection, and I need to create the object of the payment as well, equals to payment. Okay, I just want to use the builder pattern over here, so let me go to this entity, let me add the builder as well, and it says that it needs a constructor as well. So let me just create the all-args constructor and @noargs constructor as well. We should not complain, right? Now let's get back to the events handler. Let's use payment repository.builder.build, and let me add the other details as well. Dot payment ID I'll get from the event dot get payment ID, dot order ID also I'll get from the event dot get order ID, dot payment status I can say it's completed, and dot timestamp I can say new date. Okay, so this is the payment object that I have created using the builder pattern, and I need to save this. So I can just use payment repository dot save payment. So here you can see that this particular event has been handled and we are storing the data. Now the same event we need to handle as a Saga event handler as well. So let's go to the order Saga again, and we have this one particular event handler, right? Now let's go ahead and create the different one. So we can say private void handle payment processed event. Okay, and this should be annotated with again Saga event handler. It should have the association property, and I'll be using the same order ID. Okay, once the payment processed event is been handled, we need to do the ship order command, right? As per the diagram you can see we need to have a ship order command. So let's create the ship order command. This command also has to be handled by the shipping service and the order processing Saga as well. So we need to have in the common service. So let's go ahead in the common service, in the commands, let's create the new command, and we'll say as a ship order command, ship order command. This particular command will have private string shipment ID, and it will have private string order ID, which particular order we need to ship, and will have the @data, and it will have @builder annotation to have the getter setters and the builder pattern. And for every command we do target identifier, so the shipment ID would be target identifier. Okay, target aggregate identifier. Let's go back to the order processing Saga and let's create the object of it. We will say ship order command equals to ship order command.builder.build, and let's set the values as well. So we need to pass the shipment ID, that would be uuid dot get random id dot toString dot order id will get from the event, and the payload of the command has been created, ship order command. Now let's send this command using the command gateway dot send, and the command is ship order command. Let me add the loggers as well for this. Okay, log.info payment processed event in Saga for order ID, whatever the order ID it is, and this also may contain in the error, right? So let me just surround with the try catch. Let me surround with try catch over here. Okay, and if there is any exception, log that exception, log.error e dot get error message, and if there is any error we can start the compensating transaction. Simple thing. Whenever this particular payment processed event has been occurred, when we are handling that event in this particular Saga event handler, we created this command, that is ship order command, and if there is any error we will start the compensating transaction. Now this particular command we need to handle in the shipment service. So let's go to the shipment service and let's create the packages and handle this. The shipment service, let's go to the src main java and let's handle this. So let me just create the package that says command API, command.api main package. Inside that I will create the package that says aggregate. We need to create the shipment aggregate. Okay, and also we need to create the events package to handle that particular event, and we also need to have the package for the data to handle or to create the repositories. We need to rename it. It should not be events data, events, and let it create. Let's create the new data package. Okay, now in this aggregate we need to create the shipment aggregate. So let's create the Java class and let's say shipment aggregate. It should be annotated with aggregate, and this should have the values like this one, and also private string shipment status. Okay, and the shipment ID has to be annotated with aggregate identifier to match with the target aggregate identifier in the command. Okay, now this aggregate should have the constructor, that is a default constructor, and the constructor that is handling that particular command. So let's create the constructor. One should be the default constructor and one should be the constructor which is injecting the command, that is the ship order command. Now here also validate the command, and after that publish the order shipped event, and this we need to annotate with @command handler. Now this has to have the order shipped event, so we need to create the event as well. So let's go back to the common service. In the events, let's create the order shipped event. Okay, if you see this particular diagram again, ship order command will again publish the order shipped event. Okay, so that's why we created the order shipped event over here, and let's add the properties over here, and this will have whatever is in the aggregate. So if you go to the aggregate, these are the fields. Let's add that, and this should have @ data annotation, and @builder annotation, just adding the payload details. Now we need to publish this particular event, so we need to go to the aggregate. We need to create the object of it, order shipped event equals to order shipped event.builder.build pattern. We'll be using over here dot ship id will get from the ship order command, dot get shipment id, dot order id also will get from that same command, and dot shipment status will get from the here. We'll just add it is completed. So this event is created. We need to apply this event now. Aggregate lifecycle dot apply order shipped event. And now every aggregate, whenever you are publishing the event, you need to handle the event sourcing for it. So let's handle that. We will just say public void on what is the event, that is the order shipped event. Okay, and we need to annotate with @event sourcing handler. What we'll do, we'll just update this particular fields over here. So let's do that. This dot order id equals to event dot get order id. This dot shipment id equals to event dot get shipment id, and this dot shipment status equals to event dot get shipment status. So the event sourcing has been handled. Now this particular event that has been published has to be handled at two places, within the same service to store in the database, and to handle in the Saga, to handle as a Saga event handler to publish the new command. So let's do that. First, let's handle it in this particular event service to store the data. So in the events of the shipment service, we need to create the shipments event handler. So let's create the class shipments event handler. We'll annotate with @ components in the Springs radar, and we need to refactor it. Let's rename it, and I will just say events handler with H capital. Okay, and this will have a method public void on what is the event that we need to handle, that is the order shipped event, right? So order shipped event, and this is your event handler. So we'll annotate with event handler, and this particular event handler, what it will do is it will save the data in the database. So for here we need to have the repository and the entity as well to store in this particular database. So let's go ahead and create that. It is just the repetition of what we did in the payment service and the order service, right? So let me just create the Java class that says shipment, and this will have the same thing. I will just copy from here shipment id, order id. Okay, and this particular class should be annotated with @data for data setters and constructor, and should also be annotated with entity to create this as an entity. Every entity should have a primary key, so I'm just annotating id for my shipment id, which is fine. Now for this shipment we need to have a repository. So let's create the repository. It should be interface, and the name should be shipment repository, and this shipment repository would extend JP repository. It's of type shipment, and the ID is of type string. Now let's get back to the shipments event handler, and here we need to handle it, and this particular shipments event handler would require the shipment repository. So let's create the object for it, and let's auto wire. So I'll just do private shipment repository, and I will do the constructor injection over here. We need to create the object of the shipment. So shipment equals to shipment equals to new shipment, and I'll just copy the properties bin utils dot copy properties from event to shipment. Okay, and we need to save this. So I'll just use shipment repository dot save shipment. So this is nothing fancy, right? We are just saving this particular shipment in our database using this particular event handler. Now this particular event has also to be handled using the Saga event handler, because this event will again result in the another command, or it will be the end of the Saga as well, whatever is feasible, but you need to handle that event. So let's go to the order Saga. We have two events already, right? That is the order created event. The other one was payment processed event. Now let's go to the third one. Let's create public void handle order shipped event, and this should be Saga event handler, and the association property should be order ID. That is the unique for us. Okay, now that is the order shipped event. Now what will result in the order shipped event? If you go to the diagram, order shipped event will create the complete order command that will result in the completion of our order. So let's go ahead and do that. So this particular Saga event handler, that is order shipped event, will result in the complete order command. So we need to create that command. So let's go to the common service and add that in the commands. Let's add the class and let's say complete order command. I need to refactor it again. It should be complete order command. Okay, and this command should have some properties. Let's say it should be private string order ID and private string order status, and annotate with @data for getter setters and @builder pattern for our builder pattern, and your command should be annotated with target aggregate identifier for your unique field. So I've just done that. Now my command is ready. Now I need to send this particular command. So let's go to the order Saga. My command is ready. I need the object for it. Complete order command equals to complete order command dot builder dot build dot order ID I will get from the event dot order status should be approved. And here also let me just put the loggers, so you'll get to know what is happening over here, right? So order shipped event in Saga for order ID this. So this event executed over here. Now this particular command we need to send. So command gateway dot send complete order command. So this particular command has been sent using the command gateway. Now an aggregate would be handling this particular command and creating the new event, that is order completed event over here. Okay, here you can see that we are just going through the positive scenarios here. We have not created any of the negative scenarios for now. Okay, so let's first complete this one. So order completed event we will be doing. So let's do that. So this order completed event has to be handled by the order service. So let's go to the order aggregate in the order service. Okay, there is already one command handler and the event sourcing handler. So let's go ahead and create the new command handler and the new event sourcing handler. Okay, so I'll just say public void handle the command. What is the command? That is complete order command. Okay, and I need to annotate this method with @event handler. Sorry, @command handler. Okay, let me just remove the unused imports. Now here validate the command. If everything is fine, publish order completed event. So these are the two things you will be doing over here. Now assuming we just validated the command, whatever we got the details over here, and after that we will be publishing the event, that is order completed event. Now we need to create this event. So let's go to the common service and create it. So let's go to the event. Let's create the Java class that says order completed event. So this is the same that we are doing over here. That is the order completed event. Okay, and this particular order completed event will have private string order ID and private string order status, and let's annotate with @data and @builder for our getter setters and to use the builder design pattern. Simple thing. Let's get back to the order aggregate, and from here we need to publish that particular event. So let's create that order completed event equals to order completed event dot builder dot build dot order status we will get from the complete order command dot get order status dot order ID also will get from the complete order command dot get order ID. Event is created. Now let's publish this event. We'll apply this event using the aggregate lifecycle dot apply order completed event. Great, we did a lot of things, right? Don't give up, we still have something to go. Now this particular event has to be handled by two places, the same order service as well plus the order processing Saga as well. So first let's handle this particular event from the event handler for the order service and update the order details, and then we will handle using the order processing Saga as well. So let's go to the events and the order events handler. Before that, I just forgot, we need to do the event sourcing handler as well. So first let's do that. Public void on, and what is the event? That is order completed event, and we need to annotate with event sourcing handler. It should be order completed event. Okay, and from this particular event there is only one field that is going to change, that is the order status. So let me just update that only, because order ID remains the same, event.get order status. So I just updated the fields of this particular aggregate. Now let's handle this particular event in the events handler. We already have one event. Let's create the other event, that is public void on and order completed event, and annotate with event handler. You can see that everything is similar to what we are doing, right? It's just a repetition of code, but we are handling it properly in the event driven architecture. If we are doing directly monolith, this won't be that much code that we are going to do. It would be just directly implementation. But as this is a microservice and it's a distributed transactions, we are doing a lot of things to handle all the failures and all the positive scenarios. And all these particular things are going to store in each and every different database. So for payment, it has its own database. For shipment, it has its own database. Order has its own database. So all these databases are different. The common thing that we have that holds together is our Axon server and the event sourcing that we have. So that contains each and every details which is been used to handle all those particular things. Now this particular event, what we have to do over here is we need to get the same order ID and we need to update that particular order and save it again. So what we'll do, I'll just take the object of order equals to order repository dot find by ID and event.get order ID dot get. I am assuming that I will get that particular order, okay? Otherwise we can handle all the different scenarios over here. And I will do order dot set status, set order status equals to event dot get order status and order repository dot save order again. So what I did, I just got the order from the database itself, okay, with the order ID that I already have. I updated the status of the order, whatever I got from this particular event, and I saved it again. This particular event has been handled. Now the same event we need to handle using the Saga as well. So let's go ahead and do that. Now in this order processing Saga, let's create one more method over here. Let's say public void handle order completed event, and let's annotate with Saga event handler and association property equals to order ID. Okay, and let me add the loggers as well for here. and I can say order completed event in Saga for order ID, this particular order ID. Now at this particular point, if you see the diagram, you can see that it will again send the command to the send invoice command to the notification services, but we have not created the notification services. If you want, you can send another command to the notification service and it will send the email or whatever, SMS or whatever we want to do. But for now we can call it a day and we can complete the Saga as well for here, because you can see it is the same thing everywhere, right? There will be a command and we need to handle that particular command, and that particular command will publish the event, and that event has to be published in the Saga also and in the similar service also to save the data or to update the data or whatever operations that we need to do. So for now, let's call it a day and let's end the Saga over here. So what I'll do, I'll just annotate with end Saga. So that means that this particular order completed event will complete the Saga for us. Okay, so at the last, this should be the output that we are seeing over here, and after that we are not doing anything. Everything should be perfectly fine. So you can see we created a lot of different commands and we created a lot of different events. We handle all the particular events in their services plus the order processing Saga itself. This entire flow, this entire success flow has been completed. What we can do over here is we can start all the particular services and we can place one order and we can see everything is working fine. So let's go ahead and see that. If you go to the Axon server over here, our dashboard is working fine. You can see that everything is fine. Now let's go to the services over here and you can see that we have user service, shipment, payment and order service. So let's start all these 4 services. Now alongside this, you can always go ahead and implement the Spring Cloud dependencies and you can add all the API gateway, Eurekas and everything. Okay, so everything works similarly. So I have already have a video on that, so I will link in the description below for you to check that out. So here you can see that all the services are up and running: order service, payment, shipment and user service, and these are the port details. Okay, so let's go ahead and open one of the API and let's go to the H2 console. So I'll just say h2-console over here. Okay, and for the order database it is order DB, so it's there, and the username is populated. Let me add the password and login, and you can see that the orders table is created and there are other tables as well, like Saga entry and token entry and association value entry. So these are the part of the Axon framework. So let's check whatever the data is there. You can see there is no data available, and if you go to the other table as well, like Saga entry, you can see there is no entry. Okay, now what we will do, we will go to the Postman and we will hit that particular URL. So let's open Postman. Okay, and if you go to the orders controller, order command controller, you can see that we have a post mapping for the /orders over here, and for the request body, these are the fields over here. So let's add those details. So here you can see that it just added localhost 9091/orders over here, and if you go to the body section as well, I have added the same details: product ID, quantity, address ID and user ID. Product ID, user ID, address ID and quantity. Now let's hit on send over here. Okay, and you can see that the order is created. So this is the response that we have sent from the order controller. Now let's see what are the details. Now first let's see the logs as well. Okay, in the order service, let's see the logs. There is some error as well. And if you go to the Axon dashboard also, you can see that there are 4 applications connected, and you can see all the commands that we have created. Okay, all are available. You can see the different events are there. Okay, everything is available. So let's go to the H2 console. Let's see if order is updated. You can see that the order is created. Order ID, address ID, order status is created, product ID. So there is some issue, so order is not approved yet. So let's see what is the issue. I see the error is in the get constructor, so let's try to add the constructor and see if it's working or not. Let's go to the order service over here. Let's go to the order processing Saga and let's try to add the default constructor as well. Okay, so let me just add the default constructor as well. Now let's restart the service and let's start the service again. So at this particular point I'm getting the null pointer exception. I'm not getting the user card details. So let's check this. Let's go to the user service src main java projection. It is annotated with query handler. I don't know what is the error, so let me just create the controller and define this particular method there, so I can call this particular method, so we will get to know more. So let me just create the controller over here. Let me create the package. Let's say controller. Let me create the new Java class and say user controller will map with the request mapping and rest controller over here slash users. Okay, and let me create one method over here and I'll just send user back get user payment details. Okay, and let me annotate with get mapping and let me pass the path variable. I'll just say user ID. Okay, and here let me take the string user ID over here and it should be the path variable with the same user ID. And here I will just call this particular query that I have already created. So for that I will need the query gateway as well. So let me just add the query gateway, private query gateway, and I'll add the constructor injection. And the query that we are going to use is get user payment details query equals to get user payment details query, and I'll just pass the user ID over here and I'll just say user equals to query gateway dot query, and in this particular query I will pass get user details query, and what will be my return type? Response types dot instance of user dot class, and I'll just do return user and I'll just do join over here. Okay, so this is just the controller that I've added, so I will get to know more about this particular details that we are getting or not. So let me just restart this. Okay, user service. Okay, the service is started. Let me go to the postman and let me call this particular user. And I'm getting the error. Okay, I'm getting the error for the deserialization. So let me just convert the gateway objects to the transient and let's try again. Let me just do transient over here as well, and the main thing that we need to change transient to is in the order processing Saga. So let me just go there, order processing Saga. Let me just convert here transient over here. Okay, now let's restart all. Let me just restart all the services. Okay, after a little bit while of debugging, I got to know there might be some issue in the latest version of the Axon framework. So I just degraded the version to 4.5.3 instead of 4.5.4. Just change this to directly auto wire. Okay, to transient. Okay, let me just restart the service and check. Okay, the service is restarted. Let me just clear the logs. Let me go to Postman, hit on send, and here you can see that the order completed, right? So this was the issue. I'm not sure why, but seems like everything is working. Let's just check the details over here. Let's just go to the console and check. Let me just open 9091 H2 console. Let me add the password over here, and if I check the order details, and here you can see that this is the particular order and it is got approved as well, and this is the quantity 3. Don't worry about the user ID, there might be something wrong, but my order is approved. And if you check this particular Saga entries, okay, here you can see that this particular Saga entry is there, the serialized version of Saga ID and everything. There has to be token details as well. Here you can see that this is the token details for the order processing Saga. Now internally all these particular details are being used to handle our Saga. We can go ahead and see all the different details in all the different databases. Okay, so we have payment service as well. So let's go ahead and see the payment as well. /h2 console, and this is the payment DB. Let's check, it should be payments, right? Payment or payments, payment service, src main resources, and it's payment DB. Okay, the password is password. Connect to it, and there is a payment table over here. Let's run it, and here you can see that the entry is there and the payment is also completed, and the order ID last is 9819. It should match with this one. 9819, this is the particular order. Okay, and if we go to the third one, that is the shipment service, let's go ahead and check that as well. H2 console, and this should be the shipment DB. Let's check the DB details over here. It's the shipment DB. Let's copy it. Let's add the password, and there is a shipment table over here, and here you can see that this is the shipment details and the order ID is the same, 9819. So shipment is also completed. So you can see that the entire transaction has been completed successfully. Okay, so we got a couple of issues that was regarding the X1 framework. We just reverted the version to 4.5.3, but this is the entire process. And one thing to note over here is, for our order processing Saga, your command gateway and query gateway should be transient. So this is your complete Saga flow for a success one. Now we can go ahead and implement the compensating transaction as well, like whenever there is a failure, how to implement those compensating transaction. So let's go ahead and do that as well. So here for the compensating transaction flow, here you can see we have a cancel order command for the create order command when there is a failure in that, and we have the cancel payment command when there is a failure in the validate payment command, and so on for the cancel shipment command as well. So for now what we'll do, we'll just implement this particular flow, that is cancel order command and the cancel payment command. Similarly, you can implement the cancel shipment command as well. It's very easy. So when there is a failure in creating this particular event, what we'll do, on listening of this particular event, if there is any exception, we will raise this particular command to cancel that particular order. And when there is an issue in processing that particular payment, we will create this particular command, that is cancel payment command, which will emit this particular event, that is payment cancelled event, resulting into the cancellation of the order. So let's go ahead and implement this. Let's go to the IntelliJ IDEA and let's go to our order processing Saga. This is our order processing Saga over here, and we have the method that is taking order created event as the input over here. Okay, so it's handling this particular event, and here you can see that whenever we were trying to do some operations over here, and we added the command like to start the compensating transaction. So at this particular point, if I'm not getting the user payment details, right, at that time there is no need to process that particular order, so we can cancel that particular order. And if I'm getting any issue while sending the command to the command gateway for this particular validate payment command, so whenever there is issue in the validate payment command, at that particular time also I can start the compensating transaction to cancel that particular order. So let's do this. Let's create one method that will try to create this particular compensating transaction to cancel that order. So let me just create that. What I'll do, I'll just create one method, that is cancel order command, and I will pass the event dot get order ID because I just need the order ID over here. And let me just create the method in the same class. Okay, create method cancel order command in order processing Saga. Now this particular method is to handle that cancellation of order. So I need to have the cancel order command as well. Whatever we saw over here, right? This is cancel order command. So let's go ahead and create this particular command. Let me just add in the common service only directly. So in the commands, I will just add Java class cancel order command. And this particular cancel order command will have private string order ID and private string order status equals to, I'll just say cancelled. Okay, just adding the default value, and let me annotate with @value annotation from the Lombok. Okay, what it will do, it will add the getters and all our constructor for our class. So this is enough for now, and let me add the target identifier as well. Target aggregate identifier for our aggregate to handle this particular command. Now we need to handle this particular command. So to handle this particular command, what I have to do is I have to go to the order aggregate. So let me just go to the order aggregate. Let me go to the order service. In the order service, in the aggregate package, there is the order aggregate. So let's come over here and let's create one more handler. So you can see there is one handler, command handler for completed order command. Okay, and for order created command as well. Let's add one more. I'll just add public handle, public void handle, cancel order command. Okay, and this should be command handler. Now this particular command, right, cancel order command will result in creating the event, that is order cancelled event. You can see that it will create the event, that is order cancelled event, to handle out that particular scenario. So let's go ahead and create this particular event, and when this particular event is been triggered, either we can go ahead and send the alert notification like your order is cancelled, or we can end that particular Saga at that particular point as well. Let's create the event. So to create the event, we need to create the class. So let's go to the common service and create the class. For that, we'll go to the common service, and in the events, we will create the class, and we will say order cancelled event. Okay, and for this particular order cancelled, we need to add the same payload that we added in the cancel order command. So I'll just copy this information and add in the order cancelled event over here. I just don't need this particular thing because I will add from the command itself. And let me add the data annotation from the Lombok for our getter setters and constructors. Now let's go back to the order aggregate again, and in this particular handle method that is handling the cancel order command, we need to create the event. So let's create the object for it. I'll create the object, that is order cancelled event equals to new order cancelled event, and I will use the bin utils to copy the properties. Bin utils dot copy properties, and I'll copy from cancel order command to order cancelled event. And once I get this particular event, I need to apply this particular event in the aggregate lifecycle. So I'll just do aggregate lifecycle dot apply order cancelled event. Now for every command handler, whatever you are handling in the aggregate, you need to handle your event sourcing as well. So for this particular event, whatever we published, let's handle the event sourcing for that as well. So what I'll do, public void on, what is the event over here? The event is order cancelled event. So I'll just mention order cancelled event event, and I'll annotate with @event sourcing handler, and whatever the values that is being updated, we need to handle that. So this dot order status has been updated over here because order ID will remain the same, equals to event dot get order status. Now this particular event has to be handled at two places, like whatever we handled earlier as well, right? In the same order service as well, to complete this particular event and to update in the database, plus in the order processing Saga as well, to start the new particular command. So first, let's complete this particular implementation in the order service itself. We'll go to the order events handler over here, and we'll handle one event. What is the event? That is order cancelled event. So I'll just create one more method, public void on. What is the event? Order cancelled event, and this would be your event handler. So let me just annotate with event handler as well. And here what I want to do is I want to get that particular order from the database based on the order ID what I have, and I want to update the status of that particular order, like that particular order is cancelled. So what I'll do, I'll just copy all this particular thing, okay, because it's the same over here. So let me just do command C and command V over here. I'm taking the order information from here, from the order repository, find by ID, event dot get order ID dot get. So I'll get the order over here, and I'm just updating the status of that particular order from the event, and I'm saving the order back. So this particular flow is over. Now let's handle this particular event in the order processing Saga. So let's go to the order processing Saga. Now whatever that particular cancel order command, the method which we have created, we need to send that command to the command gateway as well. We forgot to add, so let's add the detail. So we'll just add cancel order command equals to new cancel order command, and here we'll pass the order ID, okay, and command gateway dot send cancel order command. So this particular method is completed. Now let's handle that particular cancelled order event. So let's go down over here and let's create the method public void handle order cancelled event, okay, and I'll annotate this particular method with @Saga event handler, which will have the association property equals to order ID, and I will add the loggers also, and I'll just mention that this is order cancelled event in Saga for order ID this, okay, because if you see this particular example over here, this is the last event. If you want, you can create one more command, that is the alert cancellation command, and that will result in the new event to send the alert notification. But for now, to understand and to make this particular video short, I'm just doing it over here. But if you want, you can go ahead and create the new command from that, and you can handle that as well. It's very easy, okay. This particular event will end the Saga for now. Now this was the one thing that we implemented. Now the other thing was to cancel the payment as well. So whenever there is an issue in the particular validate payment command as well, at that time also we will do this. So let's go and do that. So if you come to this particular point and if you see this particular method that is handling the payment processed event. So whenever there is any issue in this particular event handler, that means you need to start the compensating transaction and you need to cancel the payment, right? Because at this particular point, your payment is processed and you are going for the shipment and you got some error. So you need to cancel the payment as well, and you need to again cancel the order as well. Okay, so that is always you are at the third point of your transaction, that is your ship order command. So whenever you have to do the compensating transaction, for that you need to do C of n-1. So you need to cancel your payment plus you need to cancel your order as well. So at this point, whenever you got the exception for that, you will create the compensating transaction for your payment reversal. So let's do that. We'll create the method over here and I'll say cancel payment command, and this particular cancel payment command will take the event whatever was fired over here, so we can get all the details from that particular event. And let's create this particular method in this particular order processing Saga itself, and we need to create the command for this. So the command would be cancel payment command. If you see the example, that would be cancel payment command. So let's go ahead and do that. We'll go to the common service in the commands package. Let's create the Java class and we will say cancel payment command. Cancel payment command. And this particular class will have payment ID, like which payment to cancel, and for the order ID, which order, and the status of the payment. So let me just add the details. Private string payment ID, private string order ID, and private string payment status equals to cancelled, and I'll annotate with @value from the Lombok. And as this is your command, your unique identifier, that is your payment ID, will be annotated with target aggregate identifier. This particular command we need to send via command gateway. So let's go to the order processing Saga. In the cancel payment command, we'll create the object, that is cancel payment command. Cancel payment command equals to new cancel payment command, and we need to pass event dot get payment ID and event dot get order ID, and we will use the command gateway to send this command gateway dot send cancel payment command. Okay, now we need to handle this command in the payment aggregate, right? Because this is a part of the payment services. So let's go to the payment service over here. This is the payment service. In the payment service, Java command API aggregate, and this is the payment aggregate over here. So in this particular aggregate, there is already handle, that is validate payment command, and we will handle one more command over here. So let's create the method for it. Public void handle cancel payment command, and we'll annotate with @command handler. And this particular command handler will result in a new event, that is payment cancelled event. So we need to create the class for that as well. So let's go ahead and do that. So let me just go to the common service again. This is the common service, and in the events package, let's create a new Java class and we'll say payment cancelled. Okay, spelling is wrong. Cancelled event. And in this particular payment cancelled event, we will add the same payload details, that is cancel payment command. We'll copy these three things and we'll add over here, and let's annotate with @data from the Lombok dependency to get the getter setters and constructors. Now let's go back to the payment aggregate and let's create that particular event. So payment cancelled event equals to new payment cancelled event, and we will use the bean utils to populate the values. So we'll just say bean utils dot copy properties from cancel payment command, and to add to payment cancelled event, let's use the aggregate lifecycle dot apply to apply this particular event, that is payment cancelled event. Now for all the events that we publish, we need to handle the event sourcing handler as well. So let's do that. We'll handle the event sourcing handler. Public void on which event, that is the payment cancelled event. Payment cancelled event, and we will annotate with event sourcing handler, and we will update the values which has changed the state of this particular command. So here the only thing changed would be the payment status. So we'll just change the payment status from the event over here. Now the event is been applied. So this particular event has to be handled at two places: within the payment services from the payments event handler to update the database, plus in the order processing Saga to create a new command or to complete that particular transaction. So first let's go to the payments events handler and handle this particular event over here. So there is already payment processed event handle. Let's go ahead and handle the new one as well. So I'll just create a new method, public void on, and I'll just say payment cancelled event. Okay, and I need to annotate this with @event handler. So here I need to update the values in the database. So I need to get the payment from the database, update the status of the payment and save it back again. So let me just do that. I'll just take the object of the payment equals to, I'll get from the payment repository dot find by ID, and I'll pass the event dot get payment ID dot get. So I got the payment over here from the payment repository. Then I'll just say payment dot set payment status, whatever I got from the event, and I will save the payment again to the database, payment repository dot save payment. Cool, right? So this particular event is also been handled over here. Now this event has to be handled from the order processing Saga also. So let's go to the order processing Saga. So here let's go down and let's handle this. So what I want to handle, public void handle payment cancelled event. Okay, and this would be the @Saga event handler association property equals to order ID. Now this particular payment cancelled event will result in the cancellation of the order as well. So over here, let me just add the loggers first. So this is just handling the payment cancelled event in Saga for order ID this, and this should result in the cancellation of the order. So I'll just call the method cancel order command, and in this particular I need to pass the order ID. So from the event I'll get the order ID. Okay, so this particular payment cancelled event will call the cancellation of the order, and it will send this particular command, and it will handle this particular event to end the Saga at this particular point, order cancelled event. So your entire Saga will be completed over here. The same way you can go ahead and implement for the cancel shipment command as well. Okay, so for this particular two things, this entire process has been completed. Now let's go ahead and check this out. So here I will try to mimic a scenario where there is an issue in your shipment, so you need to revert your payment plus you need to revert your cancellation of the order as well. So what I'll do, when your payment has been processed, right, I'll go to that particular point. Your payment has been processed, right? So at this particular point I'll do if true, throw new exception. So whenever the payment process event is been handled over here, at this particular point some exception would occur, so it won't be able to handle this particular event, that is ship order command, and it will end up in the exception, that is the catch block over here, and it will cancel the payment for this. Okay, so let's rerun the application and let's test this out. Let me go to the services. Let me stop all the services. Let's start all. Okay, all the applications are started. Let me just open any one of the API over here, and let's go to the H2 console for that. And our Axon server is also running over here. 4 applications, 4 instances are been added over here. If you go to the H2 console, instead of shipment DB, just try to do order DB and password. And we have 5 entries over here. Okay, so what I'll do, I'll just go to the postman over here, and this is a particular order with product ID this, quantity I'll just change to 5 and let the user ID be same. Okay, so I'll just hit on send over here, and here you can see that it is saying the order created because we have not changed anything like what we are sending the response back. So that still remains the same, but what happened internally, that is what we are more interested on. Okay, and if I run this again, and here you can see that the new order has been created and the status of the order is cancelled for the quantity 5 and the product ID whatever we mentioned. So that means there was some issue and the cancellation was called. So if we go to the logs as well, so here you can see that it was in the payment processed event. Okay, and after that something happened, and after that the payment cancelled event was called and order cancelled event was called. So that means if we check the payment as well, that payment also should be cancelled. So let's see that as well. So if I go to the payment service application, and if I go to the H2 console for that, go to the payment DB, I'll add the password over here, and here you can see that the payment has been cancelled for the order ID 54FEF, that is 54FEF. Okay, so for that the payment is also cancelled over here. Now let's see if there is any other entries like shipment happened or not, right? So let's go to the IntelliJ IDEA. The shipment is with 9094. So let's go ahead and see that as well. H2 console. This is shipment DB. Okay, and here you can see that there is only one entry. So we do not have any entry for the order ID, that is 54FEF. We do not have any entry. So that means there were two entries created. There was some issue while doing the shipment, and the entire process before that, that is the payment and the order created, that was cancelled over here. So this way you can see that we handle the compensating transaction as well. So whatever the steps that you have done at that particular point in that Saga, you can reverse everything that you have already done. So we were at the third point of our transaction, and at that particular point we got the error, right? At this particular point we got the error. So we handled using this compensating transaction. We created a transaction to revert whatever was happened. So this way we can handle the distributed transactions across the different microservices that we have using the Saga design pattern. This is the orchestration design pattern that we have seen in detail over here. Now there are a lot more advanced topic as well available to handle these particular distributed transactions, but this is a foundation of how a particular transaction is been handled. Distributed transaction is been handled in the Saga pattern, and this is how the event sourcing and the event driven architecture will work. There will be a little bit of more code that you have to do, but the structure wise you can see that it will be very easy to understand. After that, once you get the understanding of this, it will be very easy and you will love to code in this particular way. Okay, because I did enjoy this, so I hope you will also enjoy doing this. So in this particular tutorial we completed the entire success flow as well, that is the creating the order and then doing the payment, shipment and everything, and we handle the negative scenario as well. If there is any failure, how to handle the compensating transaction as well. So we did see everything in detail over here. So if you have any doubts, then let me know in the comment section below. I will add this particular code in the GitHub and I'll share the link with you. I hope you have enjoyed this particular tutorial. I know it would be a roller coaster ride for you guys because there are a lot more difficult part as well, and once you get understanding of entire flow, then only you will get more understanding like how we are doing everything and why we did everything. So I'm happy that you sticked around till the end and completed this particular video, and I will see you in the next video. Till then, happy coding. Bye bye.